For centuries, humans believed they knew their story. But now, from the jungles of Central America to Egypt's scorching deserts, discoveries are emerging. Strange artifacts, colossal monuments, and impossible knowledge that defy explanation. Who carved precise temples from solid mountains thousands of years ago? What civilization mapped the stars with accuracy modern science struggles to match? The Antikythera mechanism is an ancient Greek analog computer discovered in a shipwreck off the coast of the Greek island Antikythera in 1901. This remarkable device, dating back to around 100 to 200 before the Common Era, continues to astound scientists with its complexity and sophistication. Constructed of bronze gears housed in a wooden case, the Antikythera mechanism was designed to predict astronomical positions and eclipses for calendrical and astrological purposes. It could also track the 4-year cycle of athletic games, similar to the ancient Olympic Games. What truly baffles modern scientists is the level of technological advancement the mechanism represents. Its intricate system of at least 30 gears, with teeth as fine as those on a clock, demonstrates our understanding of astronomical cycles and mechanical engineering far beyond what was previously thought possible for that era. The device's precision and complexity suggest a level of scientific knowledge that was not believed to exist until at least 1,000 years later. Furthermore, the Antikythera mechanism stands as a unique artifact. No other device of comparable complexity is known from the ancient world, raising questions about the extent of lost knowledge and technological capabilities of ancient civilizations. This enigmatic machine challenges our understanding of ancient Greek technology and the history of science, prompting ongoing research and speculation about its origins and purpose. Ancient civilizations developed remarkably accurate astronomical calendars through centuries of meticulous observation and record-keeping. These early skywatchers noticed repeating patterns in the movements of celestial bodies, allowing them to predict cosmic events with impressive precision. The Mayans, for instance, tracked Venus with astonishing accuracy. They observed its cycle of visibility and created a calendar that predicted its appearances over centuries. This level of precision required generations of astronomers to compile and refine their observations. In Egypt, the annual flooding of the Nile was crucial for agriculture. Priests noticed that the bright star Sirius appeared just before this vital event. By tracking Sirius, they created a calendar that helped them prepare for the floods and optimize their farming practices. Stonehenge in England demonstrates how ancient people incorporated astronomical knowledge into monumental structures. Its layout aligns with solar and lunar events, suggesting it served as a sophisticated calendar. This blending of astronomy and architecture highlights the central role celestial observations played in ancient societies, guiding both practical matters and spiritual beliefs. While there is no conclusive proof that ancient Egyptians harnessed electricity in the modern sense, some intriguing archaeological findings have sparked debate among researchers. The most famous example is the so-called Dendera light, a stone relief found in the Hathor temple at Dendera. This carving depicts what some interpret as a large light bulb, complete with a filament-like snake and a cable-like stem. Additionally, some researchers point to the lack of soot residue in certain Egyptian tombs and temples as potential evidence of electric lighting. Traditional torches or oil lamps would have left significant smoke marks on the ceilings, yet many of these ancient structures show remarkably clean interiors. Another curious artifact is the Baghdad battery, discovered in Iraq but dating to the Parthian period when Egypt was under Roman rule. This clay jar containing an iron rod surrounded by a copper cylinder bears a striking resemblance to a simple galvanic cell, leading some to speculate about its potential use as a power source in ancient times. However, mainstream archaeologists and historians remain skeptical of these claims, arguing that there is insufficient evidence to support the idea of widespread electrical knowledge in ancient Egypt. They suggest alternative explanations for these findings, emphasizing the need for caution when interpreting ancient artifacts through a modern lens. The construction of Stonehenge remains one of the most intriguing mysteries of prehistoric engineering. The massive stones, some weighing up to 26 tons, were transported over considerable distances and erected with remarkable precision using only Stone Age tools and techniques. The smaller blue stones, weighing up to 4 tons each, were quarried in the Preseli Hills of Wales, about 150 miles away from Stonehenge. Archaeologists believe these stones were likely transported using a combination of land and water routes. Wooden rollers and sleds may have been used to move the stones over land, while rafts could have carried them along rivers and sea routes. The larger sarsen stones, weighing up to 26 tons, were sourced from the Marlborough Downs, about 20 miles north of Stonehenge. These enormous blocks were probably moved using sledges and ropes, with teams of workers pulling them across the landscape. Experiments have shown that with enough people and proper organization, moving these massive stones was possible, though incredibly labor-intensive. Erecting the stones involved digging deep pits and carefully maneuvering the blocks into position. The builders likely used a system of ramps, levers, and ropes to gradually raise the stones. Once upright, the lintels were lifted into place using similar techniques, possibly with the aid of wooden scaffolding. This process required immense coordination, planning, and engineering skill, showcasing the remarkable capabilities of our Neolithic ancestors. Ancient Egypt continues to astound archaeologists and historians with evidence of sophisticated engineering and craftsmanship that seems to defy explanation. One of the most perplexing examples is the precision cutting and shaping of hard stones like granite and diorite, materials that would challenge even modern power tools. The ancient Egyptians somehow managed to create perfectly flat surfaces and right angles on massive stone blocks, often with tolerances of less than 1/100th of an inch. This level of precision is particularly evident in structures like the Great Pyramid of Giza, where enormous limestone blocks fit together so tightly that a credit card cannot be inserted between them. Even more baffling are the numerous perfectly drilled holes found in hard stone artifacts. These holes have smooth, uniform interiors and show no signs of spiral markings that would indicate the use of traditional drilling techniques. Some researchers speculate that the ancient Egyptians might have employed advanced machining methods, possibly involving ultrasonic technology or even directed energy devices. Another enigma is the creation of intricate vases and bowls with long, narrow necks carved from a single piece of hard stone. The internal hollowing of these vessels appears to have been done with remarkable precision, leaving experts puzzled about the tools and techniques used to achieve such results. These unexplained manufacturing capabilities continue to fuel debate and speculation about the true extent of ancient Egyptian technological knowledge. Ancient Roman concrete has puzzled scientists for centuries due to its remarkable durability. The secret lies in the unique mixture used by Roman builders, which differed significantly from modern concrete formulations. Roman concrete, known as opus cementicum, was made with volcanic ash, lime, and seawater, creating a chemical reaction that strengthened the material over time. The key ingredient was volcanic ash from specific sources, such as Mount Vesuvius. This ash contained aluminous and siliceous minerals that reacted with the lime and seawater to form strong, interlocking crystals. Unlike modern concrete, which typically degrades when exposed to seawater, Roman concrete actually became stronger in marine environments. Recent studies have revealed that Roman concrete contains rare calcium aluminum silicate hydrate crystals. These crystals continue to grow within the concrete matrix long after it has set, filling in cracks and voids. This self-healing property is one reason why ancient Roman structures like the Pantheon and many coastal structures have survived for millennia. Modern efforts to replicate Roman concrete have shown promise, with researchers developing mixtures that mimic its self-healing properties. These advancements could lead to more durable and environmentally friendly building materials in the future, inspired by the ingenuity of ancient Roman engineers. Damascus steel has long captivated metallurgists and historians alike. This legendary metal, known for its distinctive wavy patterns and exceptional strength, was used to forge swords of unparalleled quality in the Middle East from around 800 to 1800 CE. The swords made from Damascus steel were said to be so sharp they could slice through a falling silk scarf or cleave a hair in two. The true mystery of Damascus steel lies in its lost manufacturing process. Despite numerous attempts, modern metallurgists have been unable to fully replicate the exact technique used by ancient swordsmiths. The original method died out in the 18th century, taking with it the secrets of its creation. Some theories suggest that the unique properties of Damascus steel came from trace elements in the raw materials, possibly including carbon nanotubes that formed during the forging process. Recent research has shed some light on the composition of Damascus steel. Scientists have discovered that it contained unusually high carbon content, as well as elements like vanadium, chromium, manganese, cobalt, and nickel. These impurities, combined with specific heat treatments and forging techniques, likely contributed to the steel's remarkable properties. However, the exact combination of materials and methods remains elusive. The allure of Damascus steel extends beyond its physical properties. Its creation represents a pinnacle of ancient metallurgy, showcasing the ingenuity and skill of craftsmen who, without modern scientific understanding, created a material that still challenges our technological capabilities today. The ongoing quest to unravel the secrets of Damascus steel serves as a reminder of the knowledge and expertise of our ancestors and the enduring mysteries of the past. Ancient civilizations demonstrated remarkable ingenuity in achieving precise architectural alignments without the aid of modern tools. Their methods relied on a deep understanding of astronomy, mathematics, and natural phenomena. One key technique was the use of shadows cast by the sun. By tracking the movement of shadows throughout the day and across seasons, ancient builders could determine cardinal directions with impressive accuracy. They often used a simple tool called a gnomon, essentially a vertical stick, to cast these shadows and make their measurements. Sophisticated knowledge of the night sky also played a crucial role. Many ancient structures were aligned with specific celestial events, such as solstices or the rising of particular stars. This required careful observation and recording of astronomical cycles over long periods. The alignment process often involved creating sight lines using temporary markers or poles, which were then used as guides for permanent construction. Water levels provided another method for ensuring precision. By creating channels or basins filled with water, ancient architects could establish perfectly level surfaces and right angles. This technique was particularly useful for large-scale projects where maintaining alignment over long distances was crucial. These methods, combined with their mathematical knowledge and meticulous planning, allowed ancient civilizations to create structures with alignments that continue to amaze us today. Archaeological findings reveal that many ancient civilizations possessed sophisticated understanding of acoustics far beyond what was previously thought. The Greeks, for instance, designed their amphitheaters with remarkable acoustic properties. The Theatre of Epidaurus, built in the 4th century BCE, still astonishes modern acousticians with its ability to project even a whisper from the stage to the back rows. In South America, the Mayans and Incas incorporated acoustic elements into their architecture. At the Mayan site of Chichen Itza, the Pyramid of Kukulkan produces a chirping echo when someone claps their hands at its base. This sound remarkably resembles the call of the Quetzal bird, sacred to the Maya. Some researchers believe this was an intentional design feature, demonstrating the Mayans' grasp of complex acoustic principles. Ancient Egyptians also showed acoustic prowess in their temple designs. The Great Temple of Amun at Karnak features whispering galleries where sound travels along the walls, allowing for clear communication over long distances. This suggests that Egyptian architects had a nuanced understanding of sound reflection and transmission. Even older evidence comes from Neolithic sites like Newgrange in Ireland, built around 3200 BCE. Even older evidence comes from Neolithic sites like Newgrange in Ireland, built around 3200 BCE. Its main chamber amplifies sounds, particularly those in the range of human speech. This acoustic property might have been deliberately engineered for ritual purposes, indicating that even Stone Age cultures grasped fundamental acoustic concepts. The Mayans developed their remarkably precise calendar system through centuries of careful astronomical observations and mathematical calculations. Their keen understanding of celestial cycles allowed them to track the movements of the sun, moon, and planets with astonishing accuracy. At the heart of the Mayan calendar was the Hab, a solar calendar of 365 days. This closely matched the actual solar year, demonstrating the Mayans' advanced grasp of Earth's orbit around the sun. They supplemented this with the Tzolk'in, a ritual calendar of 260 days, which they used for religious and ceremonial purposes. The Mayans combined these two calendars to create the calendar round, a 52-year cycle. However, their most impressive achievement was the long count calendar, which could measure vast spans of time. This system used a vigesimal base 20 counting method, allowing the Mayans to calculate dates billions of years in the past and future. To achieve such precision, Mayan astronomers used sophisticated tools and structures. They built observatories and aligned their pyramids and buildings to track celestial events. This dedication to astronomy, combined with their mathematical prowess, enabled the Mayans to create a calendar system that rivals modern calculations in its accuracy. The Piri Reis map, created in 1513 by Ottoman admiral and cartographer Piri Reis, has sparked considerable debate among historians and researchers. This ancient map, which shows part of the world including the Atlantic Ocean and the Americas, has drawn attention for its apparent accuracy and inclusion of geographical features that were supposedly unknown at the time. One of the main points of controversy is the map's depiction of Antarctica. Some claim that the map shows the coastline of Antarctica as it would appear without ice, a feature that should have been impossible to know in the 16th century. This has led to speculation about advanced ancient civilizations or extraterrestrial influence. However, mainstream scholars argue that this interpretation is flawed and that the landmass in question is likely a distorted representation of South America's coast. Another contentious aspect is the map's source material. Piri Reis himself stated that he used around 20 older maps and charts as references, including some dating back to the time of Alexander the Great. This has fueled theories about lost ancient knowledge and advanced cartographic skills in earlier civilizations. Skeptics, however, point out that many of these claims are based on misinterpretations or exaggerations of the map's actual content. The debate surrounding the Piri Reis map continues to captivate both scholars and the public. While some see it as evidence of unknown ancient knowledge, others view it as an impressive but flawed document of its time, reflecting the best available information and cartographic techniques of the early 16th century. The map remains a fascinating artifact that challenges our understanding of historical geography and mapmaking. The Nazca lines, etched into the arid coastal plains of southern Peru, are an enduring mystery that continues to captivate archaeologists and the public alike. These enormous geoglyphs were created by the Nazca culture between 500 and 2,000 years ago, with most scholars agreeing that the majority of the lines were made between 100 BC and 700 AD. The purpose of these massive ground drawings remains a subject of debate among researchers. Some theories suggest they were created for astronomical or calendrical purposes, serving as a way for the ancient Nazca people to track celestial movements and seasonal changes. Others propose that the lines were part of water worship rituals, as the Nazca civilization thrived in an extremely dry environment where water was precious. Another compelling hypothesis is that the lines were meant to be seen by the gods from the sky. The Nazca people might have believed that by creating these enormous figures and geometric shapes, they could communicate with their deities or ancestral spirits. This idea aligns with the religious practices and beliefs of many ancient Andean cultures. Regardless of their original purpose, the Nazca lines stand as a testament to the ingenuity and cultural sophistication of the ancient Nazca people. Their ability to create such large-scale, precise designs without the benefit of aerial perspective continues to amaze modern observers and challenges our understanding of ancient engineering capabilities. The Baghdad Battery, discovered in Iraq in 1938, is a fascinating artifact that continues to intrigue archaeologists and historians. This ancient device, dating back to the Parthian period between 250 BCE and 224 CE, consists of a clay jar containing a copper cylinder and an iron rod. When filled with an acidic liquid like vinegar or wine, it could potentially generate a small electric current. The significance of the Baghdad Battery lies in its implications for our understanding of ancient technological knowledge. If it indeed functioned as an electrical device, it would suggest that people in the ancient Near East had discovered and harnessed electricity over 2,000 years ago, long before its official discovery in the modern era. This possibility challenges our perceptions of ancient scientific understanding and technological capabilities. However, the true purpose of the Baghdad Battery remains a subject of debate among experts. Some theories propose it was used for electroplating, a technique to coat objects with thin layers of metal, while others suggest it might have been employed for medicinal purposes or religious ceremonies. Skeptics argue that it may not have been a battery at all, but rather a storage vessel for sacred scrolls. The Baghdad Battery serves as a reminder that ancient civilizations were often more advanced than we give them credit for. It prompts us to reconsider our assumptions about the past and highlights the ingenuity of our ancestors. Whether it was truly an ancient power source or served another purpose, the Baghdad Battery continues to spark curiosity and fuel scientific inquiry into the technological achievements of ancient cultures. The perfectly spherical stone balls of Costa Rica, known as Las Bolas, are one of archaeology's most intriguing mysteries. These ancient artifacts, ranging in size from a few centimeters to over 2 meters in diameter, were created by the pre-Columbian indigenous people of Costa Rica between 500 and 2,500 years ago. Archaeologists believe these stone spheres were meticulously crafted using a technique called pecking and grinding. The process likely began with selecting large, rounded boulders of igneous rock, such as granodiorite. Skilled artisans then use smaller stones as hammers to chip away at the boulder, gradually shaping it into a rough sphere. This initial shaping process could have taken months or even years of dedicated work. Once the basic spherical shape was achieved, the craftsmen employed abrasive techniques to smooth and refine the surface. They may have used finer-grained stones, sand, and water to polish the balls to their remarkably smooth finish. The level of precision achieved in creating these nearly perfect spheres is astounding, especially considering the limited tools available to these ancient artisans. The purpose of these stone balls remains a subject of debate among researchers. Some theories suggest they were used for astronomical alignments, as symbols of status or power, or as part of religious or ceremonial practices. Regardless of their intended use, the stone balls of Costa Rica stand as a testament to the extraordinary skill and patience of their creators, leaving us in awe of their ancient craftsmanship. The Phaistos disc remains one of archaeology's most intriguing enigmas. Discovered in 1908 on the Greek island of Crete, this clay disc dates back to the Bronze Age, approximately 3,700 years ago. What makes it truly remarkable is its unique spiral of stamped symbols, unlike any other known ancient writing system. Scholars have long debated the purpose of the Phaistos disc. Some believe it could be a prayer, a magical text, or even an ancient board game. Others suggest it might be a calendar or an astronomical tool. The most widely accepted theory proposes that it contains a message, possibly a historical record or a religious text. The disc features 242 symbols arranged in a spiral pattern. These symbols appear to have been made with individual stamps, making the Phaistos disc potentially the world's earliest example of movable type printing. This sophisticated method of creation adds another layer of mystery to its purpose and origin. Despite numerous attempts, the meaning of the symbols remains undeciphered. The uniqueness of the writing system and the limited amount of text available make translation extremely challenging. Until more examples of this script are found or a breakthrough in decipherment occurs, the true purpose of the Phaistos disc will continue to fuel speculation and fascinate researchers and history enthusiasts alike. The Dropa stones, also known as the Dropa's stones, are a subject of considerable controversy and debate in archaeological circles. These disc-shaped objects were allegedly discovered in 1938 by Chinese archaeologist Qipu Tei in the Bayankara Ula Mountains of China. According to some accounts, the stones are estimated to be around 12,000 years old, though this age claim is highly disputed among mainstream scientists. The carvings on the Dropa stones are said to consist of intricate spiral grooves and strange hieroglyphic markings. Some proponents of alternative theories suggest these carvings tell the story of an alien race that crash-landed on Earth millennia ago. However, it is crucial to note that there is no scientific consensus on the meaning or authenticity of these carvings. In fact, many archaeologists and historians question the very existence of the Dropa stones. No verifiable evidence or peer-reviewed studies have confirmed their discovery or the claims made about their age and origins. The story of the Dropa stones has elements commonly found in pseudo-archaeological narratives, mixing fact and fiction. Given the lack of credible evidence, the scientific community generally regards the Dropa stones as a hoax or misidentified objects. The alleged age and meanings attributed to the carvings remain unsubstantiated, highlighting the importance of rigorous archaeological methods and peer review in understanding our past. The London hammer is an unusual artifact discovered in London, Texas in the 1930s. This object appears to be a modern hammer, complete with a wooden handle encased within a rock formation that is believed to be millions of years old. The hammer's presence in such ancient stone has led some to question established timelines of human history and technological development. Conventional archaeology holds that modern humans and their tools emerged relatively recently in Earth's history, certainly not millions of years ago. The London hammer, if genuinely ancient, would dramatically alter our understanding of human evolution and technological progress. Some claim that the hammer's material composition and craftsmanship are too advanced for the time period suggested by the surrounding rock. However, mainstream scientists remain skeptical of the London hammer's implications. They argue that the process of rock formation around the hammer could have occurred much more recently than initially thought, or that the hammer might have been inserted into a natural crack in the rock that later sealed. Critics also point out that rigorous dating methods have not been applied to the artifact itself. The London hammer continues to fuel debate between those who see it as evidence challenging established archaeological timelines and those who maintain that extraordinary claims require extraordinary evidence. This controversy highlights the ongoing tension between conventional scientific understanding and anomalous findings that seem to defy explanation within current frameworks. The Quimbaya artifacts are a remarkable collection of pre-Columbian gold objects created by the Quimbaya civilization, which flourished in what is now Colombia between 400 and 1500 CE. These exquisite pieces showcase the advanced metalworking techniques of the ancient craftsmen, demonstrating their mastery of lost wax casting and gold alloying. To create these intricate objects, Quimbaya artisans would first form a detailed wax model of the desired item. This model was then encased in clay, which was heated to melt out the wax, leaving a hollow mold. Molten gold or gold alloy was poured into this mold, filling the intricate details left by the wax. Once cooled, the clay was broken away, revealing the finished golden artifact. The Quimbaya artifacts represent a wide range of subjects, including human figures, animals, and everyday objects. Many pieces depict shamanic transformations or spiritual concepts, reflecting the complex belief systems of the Quimbaya people. Particularly famous are the so-called Quimbaya airplanes, stylized human figures with outstretched wings that some fringe theorists have controversially interpreted as ancient flying machines. These golden treasures not only showcase the artistic and technical skills of the Quimbaya civilization, but also provide valuable insights into their culture, religious practices, and daily life. The artifacts continue to captivate researchers and art enthusiasts alike, serving as a testament to the sophisticated pre-Columbian cultures of South America. The Iron Pillar of Delhi stands as a testament to ancient metallurgical mastery and has puzzled scientists for centuries. This remarkable structure, located in the Qutb complex of Delhi, India, dates back to the 4th century CE and has remained largely corrosion-free for over 1,600 years. The pillar, standing nearly 7 meters tall and weighing more than 6,000 kilograms, is made of 98% wrought iron. What makes it extraordinary is its resistance to rust, despite exposure to the harsh Indian climate for over a millennium and a half. This resistance has led to intense scientific scrutiny and debate about the techniques used by ancient Indian metallurgists. One theory suggests that a protective layer of mesowite, a compound of iron, oxygen, and hydrogen, forms on the pillar surface due to the high phosphorus content in the iron. This layer, combined with the favorable climatic conditions of Delhi, may explain the pillar's longevity. However, the exact composition and method of creating this corrosion-resistant iron remain a subject of ongoing research. The Iron Pillar of Delhi not only showcases the advanced metallurgical knowledge of ancient India, but also raises questions about lost technologies and the potential for creating more durable iron structures in the modern world. Its enduring mystery continues to inspire scientists and historians alike, serving as a bridge between ancient wisdom and contemporary scientific inquiry. The genetic disc of Peru, also known as the genetic disc of Cuzco, is a controversial artifact that has sparked debate among researchers and enthusiasts of ancient mysteries. This stone disc, measuring approximately 12 inches in diameter, is said to have been discovered near Cuzco, Peru, in the 1990s. However, its exact age and origin remain uncertain, as the artifact has not been subjected to rigorous scientific dating methods. The disc features intricate carvings that some interpret as depicting human embryonic development and genetic information. These engravings show a series of circles with various symbols and patterns, which some claim represent stages of fetal growth and DNA structures. Proponents of the disc's authenticity argue that it contains advanced knowledge of human genetics that would have been impossible for ancient civilizations to possess. Critics, however, argue that the genetic disc is likely a modern creation, possibly crafted to appeal to those interested in ancient astronaut theories or lost advanced civilizations. They point out that the disc's imagery bears a striking resemblance to modern scientific illustrations of embryos and genetic structures, which would be highly improbable for an ancient artifact. It is important to note that the scientific community generally regards the genetic disc of Peru as a pseudo-archaeological object rather than a genuine ancient artifact. Without proper provenance and scientific analysis, its true nature and age remain speculative, and its purported information about genetics should be approached with considerable skepticism. Ancient civilizations possessed remarkable medical knowledge that often surprises modern researchers. In Egypt, medical papyri dating back to 1600 BCE reveal sophisticated understanding of the human body and various treatments. These documents describe surgical procedures, including the treatment of bone fractures and even brain surgery, demonstrating a level of expertise previously thought impossible for that era. The ancient Greeks made significant contributions to medicine as well. Hippocrates, often called the father of modern medicine, established a code of ethics still relevant today. Greek physicians understood the importance of diet, exercise, and environmental factors in maintaining health, concepts that align with current medical practices. In India, Ayurvedic medicine, developed over 3,000 years ago, incorporated complex herbal remedies and surgical techniques. Ancient Indian texts describe procedures such as rhinoplasty and cataract surgery, showcasing advanced medical skills. Similarly, traditional Chinese medicine, with its holistic approach to health and detailed understanding of human anatomy, points to a sophisticated medical tradition dating back thousands of years. Archaeological evidence also supports the existence of advanced medical practices in ancient times. Skulls found with signs of trepanation, a surgical intervention involving drilling holes in the skull, have been discovered across various ancient cultures. The survival rate of these procedures, indicated by healing around the wound sites, suggests a degree of surgical skill that challenges our perceptions of ancient medical capabilities. Ancient cultures across the world developed remarkable methods for observing and tracking celestial bodies, often achieving astonishing precision without the advanced technology we have today. Their motivations were diverse, ranging from religious and agricultural needs to navigation and timekeeping. Many ancient civilizations constructed large-scale structures aligned with celestial events. The Egyptians, for instance, built the Great Pyramid of Giza with incredible accuracy, its sides aligned almost perfectly with the cardinal directions. This feat required careful observation of the night sky and sophisticated engineering techniques. In Mesoamerica, the Maya created elaborate calendars based on their astronomical observations. They tracked the movements of Venus with such accuracy that their predictions rival those made with modern equipment. Their methods involved patient, long-term observation and meticulous record-keeping over generations. Other cultures, like the ancient Polynesians, used their knowledge of the night sky for navigation across vast ocean expanses. They developed techniques to read star positions, allowing them to voyage between islands with remarkable precision. This demonstrates how necessity often drove the development of advanced astronomical knowledge in ancient societies. Ancient civilizations demonstrated remarkable metallurgical skills that often surprise modern researchers. Archaeological evidence reveals sophisticated metalworking techniques dating back thousands of years. In ancient Egypt, for instance, craftsmen produced intricate gold jewelry and ornaments as early as 3,000 years before the Common Era. These artifacts show a deep understanding of metal properties and advanced forming techniques. The Hittites of ancient Anatolia were pioneers in ironworking, developing methods to create strong iron weapons and tools over 3,000 years ago. This knowledge gave them a significant military advantage. In South America, the Moche culture of ancient Peru mastered complex gilding and alloying processes, creating stunning gold and silver artifacts with a level of skill that impressed even Spanish conquistadors. Perhaps most intriguing are the occasional discoveries of anomalously advanced metal objects. The Delhi iron pillar, standing in India for over 1,500 years, shows minimal corrosion despite exposure to the elements. Its rust-resistant properties stem from a high phosphorus content and the formation of a protective oxide layer, highlighting the sophisticated metallurgical knowledge of ancient Indian craftsmen. These examples demonstrate that our ancestors possessed far more advanced metalworking capabilities than often assumed. Their achievements in metallurgy laid the foundation for technological progress and continue to inspire modern materials science research. Ancient civilizations developed remarkable techniques for creating durable pigments and dyes that have stood the test of time. Their methods often involved using naturally occurring minerals and organic materials, combined with sophisticated processing techniques. One key to their success was the use of inorganic pigments derived from minerals. These pigments, such as ochre from iron oxides and azurite from copper carbonates, were ground into fine powders and mixed with binders like egg yolk or plant resins. The resulting paints were incredibly stable and resistant to fading, allowing them to maintain their vibrant colors for thousands of years. For fabric dyes, ancient cultures utilized various plant and animal sources. The Phoenicians, for instance, extracted a vivid purple dye from sea snails, a process so labor-intensive that the color became associated with royalty. In Central and South America, the Mayans and Aztecs created a brilliant red dye from the cochineal insect, which proved to be exceptionally color-fast. The durability of these ancient pigments and dyes was further enhanced by the artisans' deep understanding of mordants, substances used to bind colors to fabrics. They discovered that certain minerals, like alum, could be used to create chemical bonds between dyes and fibers, dramatically improving color retention. This knowledge, combined with their careful selection of raw materials and meticulous preparation methods, resulted in colors that continue to captivate us centuries later. Ancient civilizations demonstrated remarkable mathematical prowess, leaving behind evidence that continues to astound modern scholars. The Babylonians, for instance, developed a sophisticated base 60-number system over 4,000 years ago. This system allowed for precise astronomical calculations and is still used today in measuring time and angles. In ancient Egypt, the construction of the Great Pyramid of Giza showcases an advanced understanding of geometry and engineering. The pyramid's near-perfect alignment with true north and its precise proportions indicate a level of mathematical knowledge that was far ahead of its time. The Greeks made significant contributions to mathematics, with figures like Pythagoras and Euclid laying the foundations for geometry and mathematical proofs. The discovery of irrational numbers and the development of formal mathematical logic demonstrate the depth of their understanding. Halfway across the world, ancient Indian mathematicians made groundbreaking discoveries. They conceptualized zero as a number, developed the decimal system, and made significant advancements in algebra and trigonometry. These mathematical innovations spread globally, fundamentally shaping our modern understanding of mathematics and influencing scientific progress across cultures and centuries. Ancient cultures developed remarkable methods for predicting eclipses, showcasing their ingenuity and deep understanding of celestial patterns. The Babylonians, for instance, discovered a cycle called the Saros, which occurs approximately every 18 years and 11 days. During this period, the Sun, Moon, and Earth return to nearly identical positions relative to each other, allowing for accurate eclipse predictions. The ancient Chinese used detailed astronomical observations recorded over centuries to create complex calendars. These calendars tracked the movements of celestial bodies, enabling them to forecast when eclipses would occur. Their meticulous record-keeping and analysis of patterns allowed for increasingly precise predictions over time. In Mesoamerica, the Maya civilization developed sophisticated mathematical systems and calendars. They used these tools to track the movements of the sun, moon, and planets with astonishing accuracy. Their calculations allowed them to predict eclipses and other celestial events far into the future. These ancient cultures' achievements in eclipse prediction demonstrate the power of long-term observation and pattern recognition. By carefully studying the night sky over generations and developing mathematical models to explain what they saw, they laid the groundwork for modern astronomy and our current understanding of celestial mechanics. Ancient civilizations demonstrated a remarkable grasp of acoustics, as evidenced by their architectural marvels and musical instruments. The Great Ball Court at Chichen Itza in Mexico is a prime example of acoustic engineering. When standing at one end of this massive structure, a person can hear a whisper from someone standing at the opposite end, nearly 500 feet away. This sophisticated design suggests the Maya had an advanced understanding of sound propagation and reflection. In ancient Greek and Roman theaters, the placement of seats and the shape of the stage were carefully designed to amplify the actors' voices, allowing thousands of spectators to hear clearly without modern sound systems. The theatre at Epidaurus, built in the 4th century BCE, is particularly renowned for its exceptional acoustics, which remain impressive even today. Ancient Chinese bronze bells, some dating back over 3,000 years, show precise tuning and harmonics. These bells could produce 2 distinct notes depending on where they were struck, indicating a deep comprehension of musical acoustics and metallurgy. Similarly, the invention of the hydraulis, an early type of pipe organ by the ancient Greeks, demonstrates their advanced knowledge of both acoustics and fluid mechanics. The placement and design of ancient Egyptian statues, such as those at the temples of Karnak, also suggest acoustic intent. Some researchers propose that these statues were positioned to create specific sound effects during religious ceremonies, further highlighting the sophisticated acoustic knowledge of ancient civilizations. Ancient mapmakers employed a variety of ingenious techniques to create remarkably accurate maps despite lacking modern technology. They relied heavily on astronomical observations, using the positions of stars and the sun to determine latitude and longitude. Skilled navigators would sail along coastlines, carefully noting landmarks and measuring distances, using rudimentary but effective methods such as dead reckoning. One key tool was the astrolabe, an instrument that allowed mariners to measure the angles between celestial bodies and the horizon, helping them calculate their position at sea. Ancient civilizations also developed sophisticated mathematical systems to translate their observations into accurate map projections. The Greeks, for instance, had already deduced that the Earth was spherical and had even calculated its circumference with surprising precision. Land-based surveyors used techniques like triangulation, measuring angles between distant points to determine their relative positions. They would often climb to high vantage points or use tall structures to get a better view of the surrounding landscape. Over time, accumulated knowledge from traders, explorers, and local inhabitants contributed to increasingly detailed and accurate maps. Perhaps most importantly, ancient mapmakers possessed a deep understanding of geography and natural features. They carefully studied patterns in coastlines, river systems, and mountain ranges, allowing them to make educated guesses about unexplored areas. This combination of observational skills, mathematical knowledge, and geographical intuition enabled ancient civilizations to create maps that remained useful for centuries. Ancient civilizations demonstrated remarkable knowledge of chemistry, often surprising modern scientists with their sophisticated techniques and understanding. In ancient Egypt, craftsmen created vibrant pigments that have retained their color for thousands of years, showcasing an advanced grasp of chemical properties and reactions. These pigments, such as Egyptian blue, were complex compounds that required precise mixing and heating processes. Mesopotamian cultures developed intricate metallurgy techniques, including the creation of bronze alloys, which demands a nuanced understanding of metal properties and melting points. They also produced glazes for pottery that required careful control of chemical reactions during firing. In ancient China, alchemists sought to create an elixir of immortality, leading to the accidental discovery of gunpowder. This mixture of potassium nitrate, charcoal, and sulfur demonstrates a sophisticated understanding of chemical reactions and their potential applications. Chinese artisans also developed porcelain, a material that requires precise control of temperature and chemical composition. The Mayans created a unique blue pigment, now known as Maya blue, which has proven remarkably resistant to degradation over time. This pigment, made from indigo dye and a special clay, showcases an advanced understanding of chemical bonding and stability. These examples highlight that ancient civilizations possessed significant chemical knowledge, often rivaling modern understanding in specific areas. Ancient civilizations developed remarkably accurate timekeeping methods through careful observation and ingenuity. The Egyptians, for instance, created water clocks called clepsydras as early as 1500 BCE. These devices measured time by the regulated flow of water from one container to another, marking the hours with surprising precision. In Mesopotamia, the Babylonians divided the day into 24 hours, a system we still use today. They also developed sophisticated mathematical models to predict celestial events, which helped refine their timekeeping. The Mayans of Central America constructed elaborate observatories and developed a complex calendar system that tracked not only days, but also cosmic cycles with astonishing accuracy. Perhaps most famously, the ancient Greeks made significant strides in timekeeping technology. Ctesibius of Alexandria improved upon the water clock design in the 3rd century BCE, creating a more accurate and complex device. This advancement laid the groundwork for future mechanical clocks. These civilizations achieved such precision through generations of astronomical observations, mathematical calculations, and technological innovations. Their methods, while different from our modern atomic clocks, were remarkably effective for their time and formed the foundation of timekeeping as we know it today. The ancient Egyptians demonstrated remarkable engineering prowess in constructing the Great Pyramid of Giza with its precise angles. Their methods, while not as technologically advanced as modern techniques, were impressively accurate. The builders likely used a tool called a plumb bob, a weight suspended on a string, to establish vertical lines. For horizontal alignments, they employed sophisticated leveling techniques, including water-filled trenches that served as primitive spirit levels. These methods allowed them to maintain consistent angles across the massive structure. Another key to their success was meticulous planning and layout. Before construction began, architects would create a smooth, flat foundation and precisely mark out the pyramid's base. They used a square tool called a set square to ensure right angles at the corners. As the pyramid rose, workers continually checked and adjusted the angles of the sloping sides. The ancient Egyptians also had a profound understanding of geometry and mathematical principles. They used a unit of measurement called the royal cubit, which helped maintain consistency throughout the construction process. This attention to detail and mathematical precision enabled them to achieve the remarkably accurate angles we see in the Great Pyramid today. Derinkuyu, the remarkable underground city in Turkey, served multiple crucial purposes for its ancient inhabitants. This vast subterranean network, carved deep into the soft volcanic rock of Cappadocia, provided a safe haven during times of conflict and invasion. The city could accommodate thousands of people, along with their livestock and food supplies, allowing entire communities to vanish from the surface and survive underground for extended periods. The intricate design of Derinkuyu included an elaborate system of ventilation shafts, water wells, and connecting passageways that spanned several levels. This sophisticated infrastructure enabled long-term habitation and demonstrated the advanced engineering skills of its creators. The city also featured religious spaces, storage rooms, and communal areas, suggesting it was more than just a temporary shelter. Derinkuyu likely served as a refuge during various periods of history, protecting its inhabitants from different threats. It may have sheltered early Christians fleeing Roman persecution, Byzantine citizens escaping Arab invasions, and local populations seeking safety from Mongol incursions. The ability to seal off each level with massive stone doors provided an additional layer of security against intruders. Beyond its defensive purposes, Derinkuyu might have functioned as an underground trading post or a secret religious center. Its existence points to the ingenuity and adaptability of ancient civilizations in creating secure living spaces in challenging environments. The underground city of Derinkuyu stands as a testament to human resourcefulness and the lengths people will go to ensure their survival and preserve their way of life. The construction techniques used at Pumapunku in Bolivia continue to intrigue archaeologists and historians. These massive stone blocks, some weighing over 100 tons, were crafted with remarkable precision. The ancient builders likely used a combination of stone and bronze tools to shape the blocks, employing techniques such as pecking, grinding, and polishing to achieve smooth surfaces and precise angles. For cutting, they might have used harder stones like granite or quartzite as abrasives, along with sand and water to create a cutting paste. Wooden wedges, possibly soaked in water to expand and create pressure, could have been used to split larger stones. The level of precision in the cut suggests a sophisticated understanding of stoneworking techniques. Transportation of these colossal blocks remains a subject of debate. The stones were quarried from sites several kilometers away, requiring significant manpower and engineering skill to move. Theories suggest the use of wooden rollers, sleds, and ramps. The builders might have employed a system of levers and counterweights to maneuver the stones into place. Some researchers propose the use of well-organized teams of workers pulling the stones on sleds over specially prepared roads. The impressive engineering at Puma Punku demonstrates the advanced capabilities of pre-Columbian civilizations. While many questions remain about the exact methods used, ongoing research continues to shed light on the ingenuity of these ancient builders and their remarkable achievements in stone construction. Sacsayhuaman, the ancient Incan fortress overlooking Cusco in Peru, continues to baffle archaeologists and engineers with its remarkable construction. The site's most striking feature is its massive walls, built from enormous stones fitted together with astonishing precision. Some of these stones weigh over 100 tons, yet they are cut and placed so perfectly that not even a thin blade can be inserted between them. The mystery deepens when we consider the tools available to the Inca at the time. They did not have iron or steel, relying instead on bronze chisels and stone hammers. This raises the question of how they managed to cut, transport, and fit these colossal stones with such accuracy. Some stones have as many as 12 angles, interlocking seamlessly with surrounding blocks in a three-dimensional jigsaw puzzle of immense proportions. Adding to the enigma is the absence of mortar between the stones. The walls have withstood centuries of earthquakes, demonstrating remarkable stability. This feat of engineering surpasses many modern construction techniques, leading some to speculate about advanced technologies or even extraterrestrial involvement. However, most scholars attribute the achievement to the Incas' sophisticated understanding of stonework and their ability to organize large-scale labor forces. Despite extensive research, the exact methods used to build Sacsayhuaman remain elusive. Theories range from the use of plant extracts to soften stone, to ingenious levering and ramp systems for transportation. As we continue to study this architectural marvel, Sacsayhuaman stands as a testament to human ingenuity and the enduring mysteries of our ancient past. The movement of the massive Moai statues on Easter Island has long fascinated archaeologists and historians. These colossal stone figures, some weighing up to 80 tons, were transported across the island without the aid of wheels or large animals. Recent studies suggest that the ancient Rapa Nui people used a combination of ingenious techniques to move these monumental sculptures. One prevailing theory proposes that the statues were walked to their final locations. This method involved rocking the moai back and forth while gradually inching them forward, similar to how one might move a refrigerator. Teams of people would have used ropes to tilt the statue slightly and then pull it forward, repeating this process over and over. This technique explains the statue's slightly downward-angled bases and the presence of broken moai along ancient roads. Another possible method involved the use of wooden rollers or sleds. The islanders might have placed the statues on wooden platforms and then used a system of ropes and levers to pull them along prepared roads. This theory is supported by the discovery of remnants of ancient roads and the presence of trees on the island during the time of Moai construction. It's likely that a combination of these methods was used, depending on the terrain and the size of the statue being moved. The transportation of the Moai was undoubtedly a monumental task, requiring significant planning, cooperation, and engineering skill from the ancient Rapa Nui people. Their achievement continues to impress and intrigue us today, serving as a testament to human ingenuity and determination. The geoglyphs at Nazca, located in southern Peru, have puzzled researchers and captivated the public for decades. These enormous designs, etched into the desert floor, depict various figures including animals, plants, and geometric shapes. Some of these lines stretch for kilometers, forming images only fully visible from the air. While their exact purpose remains a mystery, archaeologists have proposed several theories. One prominent idea suggests the geoglyphs served as astronomical calendars, helping the ancient Nazca people track seasonal changes crucial for agriculture. Others believe these massive drawings were created as offerings to the gods, visible from the heavens. Another intriguing hypothesis posits that the lines were used in religious ceremonies, possibly as ritual pathways. Participants may have walked along these designs during important events or festivals. Some researchers even speculate that the geoglyphs might have marked underground water sources, vital in the arid Nazca Desert. Despite ongoing research, the true purpose of the Nazca lines continues to elude definitive explanation. Their creation, dating back to between 400 and 600 Common Era, represents an impressive feat of ancient engineering and artistic vision. The enduring mystery of the Nazca geoglyphs serves as a testament to the ingenuity and complexity of early human civilizations. The colossal stones used in the construction of the Temple of Jupiter at Baalbek in Lebanon have long puzzled archaeologists and engineers. These enormous limestone blocks, some weighing up to 1,000 tons, were quarried and transported over considerable distances in ancient times. The most likely method for moving these massive stones involved a combination of ingenious techniques. Ancient builders likely used wooden rollers and sleds, leveraging the power of hundreds, if not thousands, of workers. They may have employed a system of ropes and pulleys to help distribute the weight and make the stones easier to maneuver. Another theory suggests that the builders might have used earthen ramps, gradually building them up as the construction progressed. This method would have allowed them to slowly move the stones into place, using a combination of muscle power and clever engineering. Some researchers have proposed that the ancient builders might have used water to their advantage, potentially floating the massive stones on rafts along rivers or canals to bring them closer to the construction site. While this method remains speculative, it highlights the innovative thinking that may have been employed in this monumental undertaking. The transportation of these immense stones remains a testament to the remarkable skills and determination of ancient engineers and laborers. Göbekli Tepe, an ancient site in southeastern Turkey, presents archaeologists with a fascinating enigma. This complex of massive stone pillars and circular enclosures was built over 11,000 years ago, predating the invention of pottery, metallurgy, writing, and even agriculture as we know it. The mystery deepens when we consider the sophistication of its construction. These stone pillars, some weighing up to 20 tons, were quarried, transported, and erected with precision that seems impossible for hunter-gatherer societies. The pillars are adorned with intricate carvings of animals and abstract symbols, showcasing artistic skills far beyond what was previously thought possible for that era. Perhaps the most perplexing aspect is the purpose of Göbekli Tepe. Unlike later temples or settlements, there is no evidence of permanent habitation at the site. Some researchers suggest it might have been a ceremonial center, drawing people from hundreds of miles around, but this raises more questions. How did a pre-agricultural society organize and feed the workforce needed for such a monumental project? The existence of Göbekli Tepe challenges our understanding of the Neolithic revolution. It suggests that complex social organization and monumental architecture may have preceded and perhaps even driven the development of agriculture. This turns our previous theories about the rise of civilization on their head, leaving archaeologists and historians grappling with a profound mystery about the capabilities of our ancient ancestors. The massive stone structures at Ollantaytambo in Peru continue to astound archaeologists and engineers alike. These enormous blocks, some weighing over 50 tons, were quarried, shaped, and fitted together with remarkable precision. The Inca, who built this site in the 15th century, demonstrated extraordinary skill in stone masonry. The process likely began with selecting suitable stones from quarries located high in the nearby mountains. Using bronze chisels, hammerstones, and possibly wooden wedges, Inca stonemasons shaped these massive blocks. They employed a technique called stone flaking, gradually chipping away at the rock to achieve the desired form. To fit the stones so tightly together, the Inca used a method known as ashlar masonry. This involved carefully shaping each stone to fit precisely with its neighbors, often creating complex, interlocking patterns. The stones were then transported to the construction site, likely using a combination of sleds, ramps, and sophisticated rope systems. At the site, final adjustments were made to ensure a perfect fit. The Inca may have used a technique called scribing, where they would place a stone in position, mark where it touched its neighbors, and then remove it for further shaping. This painstaking process resulted in the incredibly tight seams we see today, often so precise that not even a knife blade can be inserted between stones. The enigmatic structures at Yonaguni Monument, located off the coast of Japan, have sparked intense debate among scientists and researchers. These underwater formations, discovered in 1987 by a local diver, feature step terraces, flat surfaces, and sharp angles that some argue are too precise to be natural. Proponents of the artificial origin theory suggest that these structures could be the remnants of an ancient civilization, possibly dating back to the last ice age. They believe the monument might have served as a ceremonial center, a defensive structure, or even an astronomical observatory. The presence of what appears to be a carved human face and animal-like figures adds weight to this interpretation. However, many geologists argue that the Yonaguni Monument is a natural formation, shaped by the forces of erosion and tectonic activity over millions of years. They point out that the area is prone to earthquakes, which could have caused the rock to fracture along regular lines, creating the appearance of artificial steps and terraces. The true purpose and origin of the Yonaguni Monument remain uncertain. Whether natural or artificial, these underwater structures continue to captivate researchers and the public alike, serving as a reminder of how much we have yet to learn about our planet and its history. Ancient civilizations, particularly the ancient Greeks, made remarkable observations of the night sky that led to the discovery of the precession of the equinoxes. This phenomenon, a slow rotation of the Earth's axis, was first accurately described by the Greek astronomer Hipparchus in the 2nd century BCE. Hipparchus compared his own careful measurements of stellar positions with those recorded by earlier astronomers, notably Timacharis, who had made observations about 150 years earlier. He noticed that the positions of stars had shifted slightly in relation to the equinoxes, the points where the celestial equator intersects the ecliptic. To calculate this precession, ancient astronomers used several methods. They observed the changing positions of stars relative to the horizon at specific times of the year, particularly during equinoxes and solstices. They also tracked the positions of stars in relation to important celestial markers, such as the pole star. The accuracy of these ancient calculations is truly astounding, considering the limited tools available. Hipparchus estimated the rate of precession to be about 1 degree every 100 years. Modern measurements show the actual rate to be about 1 degree every 72 years, making the ancient calculation remarkably close to the true value. This achievement highlights the dedication and observational skills of early astronomers who laid the groundwork for our modern understanding of celestial mechanics. Contrary to popular belief, there is no convincing evidence that ancient cultures knew about planets not visible to the naked eye. The planets known to ancient civilizations were those that can be seen without telescopes: Mercury, Venus, Mars, Jupiter, and Saturn. These celestial bodies were observed and tracked by various cultures around the world, including the Babylonians, Egyptians, Greeks, and Mayans. Ancient astronomers were remarkably skilled at observing and predicting the movements of these visible planets. They created complex calendars and mathematical models to track their positions in the night sky. However, their knowledge was limited to what could be seen with the unaided eye. Uranus, Neptune, and Pluto were only discovered after the invention of the telescope in the 17th century. Uranus was first observed in 1781 by William Herschel, Neptune in 1846 by Johann Gottfried Galle, and Pluto in 1930 by Clyde Tombaugh. These discoveries relied on advanced optical technology and mathematical predictions that were not available to ancient cultures. Some fringe theories suggest that certain ancient artifacts or texts hint at knowledge of these outer planets, but these claims are not supported by mainstream archaeological or astronomical evidence. The ability to detect planets beyond Saturn required technological advancements that simply did not exist in ancient times. The Mayan civilization's precise calculations of Venus's orbit stand as a testament to their advanced astronomical knowledge and observational skills. These ancient Mesoamericans tracked Venus's movements across the sky with remarkable accuracy, achieving results that rival modern calculations. The Mayans' success stemmed from their patient and meticulous approach to celestial observation. Over generations, they recorded Venus's appearances and disappearances, noting its cyclical pattern. This long-term data collection allowed them to refine their calculations and predictions over time. Central to their method was the use of the Dresden Codex, an ancient Mayan book that contained detailed astronomical tables. These tables tracked Venus's synodic period, the time it takes for the planet to return to the same position in the sky relative to Earth and the Sun. The Mayans calculated this period as 584 days, which is remarkably close to the modern value of 583.92 days. The Mayans' understanding of Venus's orbit was not merely academic, it held great cultural and religious significance. They used their knowledge to time important rituals and make decisions about warfare and agriculture. This practical application of astronomical knowledge further motivated their pursuit of accuracy, leading to refined observations and calculations that continue to impress us today. The ancient Egyptian pyramids have long fascinated archaeologists and astronomers alike due to their remarkable astronomical alignments. These massive structures, built over 4,000 years ago, demonstrate an astonishing level of precision in their orientation to celestial bodies and cardinal directions. The most famous example is the Great Pyramid of Giza, which aligns almost perfectly with true north. The accuracy of this alignment is within a fraction of a degree, an impressive feat considering the tools and technology available to the ancient Egyptians. This precision suggests a deep understanding of celestial movements and advanced surveying techniques. Many researchers believe the Egyptians used the stars for alignment, particularly the circumpolar stars that never set below the horizon. These stars would have provided a constant reference point for the builders. Some theories propose that the Egyptians might have used the star Thuban, which was the North Star during the time of pyramid construction, as a guide for their alignments. The mystery deepens when considering the alignment of other structures within the pyramid complexes. Some researchers have found correlations between the positions of the pyramids and certain star constellations, particularly those in Orion's belt. This has led to speculation about the pyramids serving as terrestrial maps of the heavens, though these theories remain controversial within the scientific community. Ancient cultures developed remarkable methods for predicting solar and lunar eclipses, showcasing their ingenuity and observational skills. The key to their success lay in meticulous record-keeping and pattern recognition over many generations. Babylonian astronomers, for instance, discovered the Saros cycle, a period of approximately 18 years and 11 days after which the Sun, Moon, and Earth returned to nearly the same relative positions. This cycle allowed them to predict when eclipses were likely to occur with impressive accuracy. The ancient Chinese also made significant strides in eclipse prediction, using a system called the Siphon calendar. This calendar divided the sky into regions and tracked the movements of celestial bodies, enabling astronomers to forecast eclipses and other astronomical events. The Maya civilization of Central America developed their own sophisticated calendar system, which included eclipse tables. These tables were based on careful observations and calculations, allowing Maya astronomers to predict eclipses far into the future. Similarly, ancient Indian astronomers used complex mathematical models to calculate the movements of the sun and moon, leading to accurate eclipse predictions. It is important to note that while these ancient methods were remarkably precise for their time, they were not perfect. Occasional errors did occur, and predictions were sometimes off by days or even months. Nonetheless, the ability of ancient cultures to predict eclipses with such regularity demonstrates their deep understanding of celestial mechanics and their commitment to astronomical observation and record-keeping. There is no credible evidence to suggest that ancient civilizations understood the concept of dark matter as we know it today. Dark matter is a modern scientific concept that emerged in the 20th century, long after ancient civilizations had faded into history. The idea of dark matter was first proposed in the 1930s by Swiss astronomer Fritz Zwicky. He observed that galaxies in the Coma cluster were moving much faster than expected based on their visible mass. This led him to hypothesize the existence of unseen matter that was influencing the galaxies gravitationally. However, it was not until the 1970s that the concept of dark matter gained widespread attention in the scientific community. Vera Rubin and Kent Ford provided compelling evidence for dark matter through their observations of galactic rotation curves. They found that stars at the edges of galaxies were moving much faster than predicted by the visible mass of the galaxies. While ancient civilizations made remarkable astronomical observations and developed sophisticated calendars, their understanding of the universe was limited to what they could see with the naked eye. The technology and scientific knowledge required to detect and conceptualize dark matter simply did not exist in ancient times. The ancient builders of Stonehenge demonstrated a remarkable understanding of celestial movements, particularly lunar cycles, in their monumental creation. This prehistoric structure, located in Wiltshire, England, was carefully designed to align with both solar and lunar events, showcasing the astronomical knowledge of its Neolithic creators. The lunar alignments at Stonehenge are particularly intriguing. The monument's layout corresponds to the moon's extreme positions in its 18.6-year cycle. This cycle, known as the lunar standstill cycle, determines the moon's maximum and minimum declinations. The builders positioned specific stones to mark these lunar events, allowing observers to track and predict the moon's complex movements. One of the most notable lunar features is the presence of the 4 station stones. These stones form a rectangle that aligns with the moon's most northerly and southerly rising and setting points. This alignment would have enabled the builders to observe and record the moon's movements over extended periods, potentially for agricultural, ceremonial, or calendrical purposes. The incorporation of lunar cycles into Stonehenge's design suggests that its builders possess sophisticated knowledge of astronomy and engineering. This understanding allowed them to create a structure that served not only as a monument, but also as a complex astronomical calculator, connecting the earthbound observers with the celestial dance of the moon. The Antikythera mechanism, an ancient Greek analog computer discovered in a shipwreck, encodes remarkable astronomical knowledge from over 2,000 years ago. This intricate device, composed of bronze gears and dials, demonstrates a sophisticated understanding of celestial movements and cycles. At its core, the mechanism tracks the motions of the Sun, Moon, and the 5 planets known to the ancient Greeks: Mercury, Venus, Mars, Jupiter, and Saturn. It accurately predicts solar and lunar eclipses following the complex metonic cycle of 19 years. This cycle aligns the lunar and solar calendars, allowing for precise long-term predictions of celestial events. The device also incorporates the Callipic and Saros cycles, further refining its astronomical calculations. It can determine the phase of the moon on any given date, and even accounts for the moon's elliptical orbit, showing an understanding of celestial mechanics that was not fully explained until Johannes Kepler's work in the 17th century. Perhaps most impressively, the Antikythera mechanism includes a gear system that models the retrograde motion of planets, a phenomenon where planets appear to move backward in the sky from Earth's perspective. This feature reveals that ancient Greek astronomers had developed sophisticated mathematical models to explain complex celestial observations, challenging our perceptions of early scientific knowledge. Ancient Polynesian navigators were masters of the sea, using a sophisticated system of wayfinding to chart courses across thousands of miles of open ocean. These skilled seafarers relied on a deep understanding of natural phenomena and keen observation to guide their voyages. At the heart of their navigation technique was the careful study of celestial bodies. Polynesian wayfinders memorized the rising and setting positions of stars throughout the year, using them as fixed points to determine direction and latitude. They also observed the sun's path and the moon's phases to further refine their position and timing. Ocean swells played a crucial role in Polynesian navigation. Experienced navigators could feel the direction and rhythm of waves, using this information to maintain course even when stars were obscured. They also paid close attention to wind patterns, cloud formations, and the behavior of seabirds, which often indicated the presence of land. Perhaps most remarkably, Polynesian navigators developed the concept of itak, a mental mapping system that allowed them to envision their canoe as stationary while islands moved around them. This unique perspective helped them track progress and adjust course as needed, enabling successful voyages across vast stretches of the Pacific Ocean. Ancient cultures demonstrated a remarkable understanding of celestial mechanics, including the concept of parallax. One compelling piece of evidence comes from the ancient Egyptians. They used a tool called a merket, essentially a sighting instrument, to track the movement of stars throughout the year. This device allowed them to observe how certain stars appeared to shift position relative to others, a phenomenon we now recognize as stellar parallax. The ancient Greeks also showed an understanding of parallax. Hipparchus, a renowned astronomer from the 2nd century BCE, attempted to measure the distance to the moon using parallax techniques. Although his measurements were not entirely accurate by modern standards, the fact that he employed this method reveals a sophisticated grasp of how celestial objects appear to move when viewed from different points on Earth. In ancient China, astronomers developed intricate models of the cosmos that accounted for the apparent movement of celestial bodies. Their star maps and calendars, some dating back to the 4th century BCE, show a nuanced understanding of how the positions of stars change over time and from different viewing locations. This knowledge implicitly incorporates the principles of parallax. Even in the Americas, ancient cultures like the Maya built observatories aligned with specific celestial events. Their ability to predict astronomical phenomena with remarkable accuracy suggests they understood how the apparent positions of celestial objects could change based on the observer's location, a fundamental aspect of parallax. The Voynich manuscript is one of the most perplexing and enduring enigmas in the world of historical documents. This mysterious book, dating back to the early 15th century, has confounded scholars, cryptographers, and linguists for centuries. Its pages are filled with an unknown script, bizarre illustrations of plants, astronomical diagrams, and what appear to be medicinal recipes. The manuscript takes its name from Wilfrid Voynich, a rare book dealer who acquired it in 1912. However, its origins and purpose remain shrouded in mystery. The text is written in a language or code that has defied all attempts at decipherment, despite the efforts of some of the world's most brilliant minds, including cryptographers from both world wars. Adding to the intrigue, the manuscript features strange illustrations of unidentifiable plants, cosmic diagrams that don't match known constellations, and drawings of naked women in green baths connected by elaborate pipe systems. These peculiar images have led to numerous theories about the manuscript's content, ranging from an herbal medicine guide to an alchemical text or even an elaborate hoax. Despite modern technology and advanced analytical techniques, the Voynich manuscript continues to guard its secrets. Its resistance to decoding has made it a subject of endless fascination, sparking debates about its authenticity, purpose, and the identity of its creator. The manuscript stands as a testament to the enduring power of mystery and the human drive to unravel the unknown. Scientists have employed various methods in their efforts to unravel the mysteries of the Rongorongo script from Easter Island. This unique writing system, found on wooden tablets and other artifacts, has puzzled researchers since its discovery in the 19th century. One approach has been comparative analysis, where experts have attempted to draw parallels between Rongorongo and other known writing systems from Polynesia and beyond. Linguists have scrutinized the patterns and structures within the script, hoping to identify similarities with deciphered languages that might provide clues to its meaning. Another technique involves statistical analysis of the symbols and their arrangements. By studying the frequency and positioning of different glyphs, researchers aim to discern patterns that could indicate grammatical structures or repeated words. This method has yielded some insights into the possible nature of the script, though a full translation remains elusive. Ethnographic research has also played a crucial role, with scientists interviewing Easter Island natives and studying traditional folklore for potential connections to the Rongorongo texts. While much of the original knowledge about the script has been lost over time, these efforts have provided valuable context for understanding the cultural significance of the tablets and the possible topics they might address. Researchers studying the Indus Valley script encounter numerous obstacles in their quest for understanding. This ancient writing system, used in the Indus Valley civilization over 4,000 years ago, remains one of the world's great undeciphered scripts, presenting a tantalizing mystery for archaeologists and linguists alike. One major challenge is the lack of a bilingual text, similar to the Rosetta Stone that helped decipher Egyptian hieroglyphs. Without such a key, researchers struggle to match the Indus symbols to any known language or meaning. Additionally, the brevity of most Indus inscriptions, typically consisting of only 5 to 6 characters, provides limited context for decipherment attempts. The script's vast symbol set, numbering over 400 distinct signs, further complicates matters. This large inventory suggests a complex writing system, possibly combining both logographic and phonetic elements. Researchers also grapple with determining the direction in which the script should be read, as it appears in both left-to-right and right-to-left orientations. Compounding these difficulties is the absence of contemporary literary accounts describing the Indus Valley civilization. Unlike other ancient cultures that left extensive written records, the Indus people left no known historical texts or descriptions of their society, leaving researchers with little cultural context to aid in deciphering their enigmatic script. The Dispilio tablet is an ancient artifact that dates back approximately 7,000 years. Discovered in 1993 near Lake Castoria in northern Greece, this remarkable find has intrigued archaeologists and linguists alike. The tablet is made of wood and bears enigmatic markings that some researchers believe could represent one of the earliest forms of written communication ever found in Europe. The markings on the Dispilio tablet consist of a series of symbols etched into its surface. While the exact meaning of these symbols remains a subject of debate, they appear to be organized in a deliberate pattern, suggesting they may convey specific information. Some experts propose that the tablet might contain a form of proto-writing, possibly used to record early mathematical concepts, astronomical observations, or even rudimentary language. The significance of the Dispilio tablet lies not only in its age, but also in its potential to reshape our understanding of the development of writing systems. If the markings on the tablet are indeed a form of proto-writing, it would predate the earliest known European writing systems by several thousand years. This possibility challenges conventional theories about the origins and spread of written communication in prehistoric Europe. Despite ongoing research, the full meaning of the Dispilio tablet remains elusive. Its existence raises fascinating questions about the cognitive abilities and cultural sophistication of Neolithic societies in the region. As scientists continue to study this ancient artifact, it serves as a tantalizing glimpse into the intellectual world of our distant ancestors, hinting at the complex ways they may have recorded and transmitted information long before the advent of formalized writing systems. The Phaistos disc stands out as one of archaeology's most intriguing and perplexing artifacts. Discovered in 1908 on the Greek island of Crete, this clay disc bears a unique spiral of stamped symbols unlike any other known ancient writing system. Its significance lies in its potential to reveal an entirely new and undeciphered script from the Minoan civilization. What makes the Phaistos disc particularly remarkable is the method of its creation. The symbols were not individually carved or written, but instead stamped into the clay using a set of distinct punches. This early example of movable type printing predates Gutenberg's printing press by over 3 millennia, suggesting a level of technological sophistication previously unrecognized in Bronze Age Crete. Despite decades of study, the meaning of the disc's 141 symbols remains a mystery. Scholars have proposed numerous interpretations, ranging from a solar calendar to a religious text or even a board game. However, the limited nature of the sample, with no other examples of this script found to date, has prevented a definitive decipherment. The Phaistos disc continues to challenge our understanding of ancient Mediterranean cultures and their capabilities. Its unique writing system serves as a reminder that there may be entire chapters of human history and linguistic development yet to be uncovered, waiting silently in the archaeological record to revolutionize our perception of the ancient world. Linear A, the writing system used by the Minoan civilization on the island of Crete from about 1900 to 1450 BCE, remains one of the great unsolved mysteries in the field of linguistics. Despite decades of research and numerous attempts, scholars have made limited progress in deciphering this ancient script. The challenge lies in the lack of a bilingual text, similar to the Rosetta Stone, which could provide a key to understanding Linear A. Unlike its successor, Linear B, which was deciphered in the 1950s and found to represent an early form of Greek, Linear A continues to resist translation efforts. Researchers have identified about 700 different signs in Linear A, including syllabic and ideographic characters. Some signs appear similar to those in Linear B, allowing for tentative sound values to be assigned. However, the underlying language represented by Linear A remains unknown, further complicating decipherment attempts. Recent advancements in computer technology and artificial intelligence have opened new avenues for tackling Linear A. Researchers are now using sophisticated algorithms to analyze patterns and frequencies in the script, hoping to uncover clues about its structure and meaning. While progress has been slow, each new discovery brings us closer to unlocking the secrets of this enigmatic writing system and shedding light on the mysterious Minoan civilization. The Rohonk Codex is an enigmatic manuscript that has puzzled scholars and cryptographers for centuries. This mysterious book, consisting of 208 pages filled with unusual symbols and illustrations, was discovered in Hungary in the early 19th century. Its origin, purpose, and contents remain unknown, making it one of the most intriguing unsolved puzzles in the world of historical texts. The Codex is written in a unique script that has defied all attempts at decipherment. Experts have identified nearly 500 distinct symbols in the text, but their meanings continue to elude researchers. Some scholars have suggested that the script might be a complex cipher, while others propose it could be an entirely invented language. The illustrations accompanying the text depict religious scenes, astronomical diagrams, and military activities, adding another layer of complexity to the mystery. Numerous theories have been proposed about the origins of the Rohonk Codex. Some researchers believe it to be a medieval religious text, possibly created by a secret society or esoteric group. Others argue that it might be a hoax crafted in the 18th or 19th century to deceive collectors of rare manuscripts. Despite extensive analysis using modern technology, including spectral imaging and computer-aided cryptography, the true nature of the codex remains elusive. The Rohonk Codex continues to captivate researchers and enthusiasts alike, representing a tantalizing challenge in the fields of linguistics, cryptography, and historical analysis. As technology advances and new approaches to decoding ancient texts emerge, many hope that the secrets of this mysterious manuscript will finally be revealed, shedding light on its creator, purpose, and the information contained within its cryptic pages. The Etruscan Golden Books, also known as the Pyrgi tablets, date back to around 500 years before the Common Era. These ancient artifacts were discovered in 1954 during an archaeological excavation at the site of Pyrgi, a port city of the Etruscan civilization located in what is now Italy. These remarkable objects consist of 3 thin sheets of gold, each carefully inscribed with text. 2 of the tablets are written in the Etruscan language, while the third is in Phoenician. This bilingual nature of the tablets has proven invaluable to scholars, aiding in the decipherment and understanding of the Etruscan language, which had long been a mystery. The content of these golden books is primarily religious in nature. They document the dedication of a shrine or temple to the Etruscan goddess Uni, who was later associated with the Roman goddess Juno. The texts describe offerings made by the Etruscan ruler Thefari Velianus to the goddess, likely in gratitude for her divine support. These golden books provide a rare glimpse into Etruscan religious practices and beliefs, as well as their interactions with other Mediterranean cultures. Their preservation and discovery have significantly contributed to our understanding of this ancient civilization that flourished in central Italy before the rise of Rome. Researchers studying Proto-Elamite script encounter several significant obstacles in their quest to decipher this ancient writing system. One of the primary challenges is the limited number of surviving texts, with only about 1,700 clay tablets discovered so far. This scarcity of source material makes it difficult for scholars to gather enough data for comprehensive analysis and comparison. Another major hurdle is the lack of a bilingual text, similar to the Rosetta Stone that helped decode Egyptian hieroglyphs. Without such a key, researchers struggle to establish reliable connections between Proto-Elamite symbols and their meanings. The absence of any known descendant scripts or related writing systems further complicates the decipherment process, as linguists cannot rely on comparative methods to unlock its secrets. The complexity of the script itself poses additional challenges. Proto-Elamite contains over 1,000 unique signs, many of which appear to have multiple meanings or functions. This high degree of complexity, combined with inconsistencies in how scribes used the symbols, makes it extremely difficult for researchers to identify patterns or establish a coherent system of interpretation. Furthermore, the cultural context of the Proto-Elamite civilization remains largely unknown, leaving scholars with limited understanding of the social, economic, and religious factors that might have influenced the development and use of the script. This lack of contextual information hinders efforts to infer meaning from the symbols based on their likely subject matter or purpose. The Sitovo inscription, discovered in 1962 near the village of Sitovo in Bulgaria, remains one of the most intriguing and enigmatic archaeological finds in the Balkans. Despite decades of research, attempts to decipher this mysterious rock carving have yielded limited progress, leaving scholars and linguists puzzled. The inscription, carved into a rock face, consists of about 50 symbols arranged in several lines. These symbols bear resemblance to various ancient writing systems, including Greek, Phoenician, and Thracian scripts, but do not match any known language precisely. This unique characteristic has led to numerous theories about its origin and meaning. Over the years, researchers have proposed various interpretations, ranging from an early form of Proto-Bulgarian to a secret code used by ancient Thracian tribes. Some experts argue that the inscription might be a type of calendar or astronomical record, while others suggest it could be a religious text or a royal proclamation. However, none of these theories have gained widespread acceptance in the academic community. Recent advancements in digital imaging and computational linguistics have allowed for more detailed analysis of the inscription. These technologies have helped in creating clearer images of the symbols and comparing them with larger databases of ancient scripts. Despite these efforts, a definitive translation or understanding of the Sitovo inscription remains elusive, continuing to captivate archaeologists and linguists worldwide. Archaeological findings and ancient texts provide intriguing evidence that ancient Egyptians conducted sophisticated surgical procedures. The Edwin Smith Papyrus, a medical document dating back to 1650 BCE, describes detailed surgical techniques for treating wounds and injuries. This text reveals a surprising level of anatomical knowledge and surgical skill for its time. Examinations of mummies have uncovered signs of complex medical interventions. Some mummies show evidence of limb amputations with signs of healing, indicating successful surgeries and post-operative care. Researchers have also found skulls with precisely carved holes, suggesting the practice of trepanation, a procedure to relieve pressure on the brain. Dental procedures were also performed in ancient Egypt. Several mummies have been discovered with evidence of root canal treatments and dental prosthetics. These findings indicate that Egyptian dentists possessed advanced skills and tools to address various oral health issues. The ancient Egyptians also developed specialized surgical instruments, as evidenced by discoveries in tombs and temples. These tools, made from materials such as copper and bronze, were designed for specific medical procedures, further supporting the notion that complex surgeries were performed in ancient Egypt. Ancient Chinese practitioners developed acupuncture through centuries of careful observation, trial and error, and a holistic understanding of the human body. Their approach was rooted in the concept of qi, or life energy, which they believed flowed through specific pathways in the body called meridians. These early practitioners mapped out these meridians by noting areas of the body that seemed connected in terms of pain or other sensations. They identified specific points along these pathways where stimulation appeared to produce therapeutic effects. This process was refined over many generations, with successful techniques being passed down and improved upon. Interestingly, modern research has shown that many traditional acupuncture points correspond to areas with high concentrations of nerve endings or blood vessels. This suggests that ancient practitioners were able to identify physiologically significant locations without the benefit of modern anatomical knowledge. While their explanations for how acupuncture worked were based on concepts like qi rather than modern biology, the empirical approach of these early practitioners allowed them to develop a sophisticated and often effective system of treatment that continues to be studied and used today. The ancient Indian medical system of Ayurveda has long fascinated scholars and medical practitioners due to its surprisingly advanced knowledge for its time. Dating back over 5,000 years, Ayurvedic texts contain detailed information on anatomy, physiology, and complex surgical procedures that seem far ahead of their era. One of the most intriguing aspects of Ayurvedic medicine is its understanding of the human body. These ancient texts describe bodily systems and organs with remarkable accuracy, including the circulatory system and the role of the heart in pumping blood. This knowledge predates similar discoveries in Western medicine by centuries, raising questions about how such insights were gained without modern scientific equipment. Equally perplexing are the surgical techniques described in Ayurvedic texts. They detail procedures for treating cataracts, removing kidney stones, and even performing plastic surgery, complete with instructions for instruments and post-operative care. The level of sophistication in these procedures is unexpected for the time period, leading some researchers to speculate about possible advanced technologies or observational methods lost to history. The mystery deepens when considering the holistic approach of Ayurveda, which emphasizes the interconnectedness of mind, body, and spirit in maintaining health. This concept, once dismissed by Western medicine, is now gaining recognition in modern healthcare practices. The question remains, how did the ancient Indians develop such a comprehensive and in many ways prescient understanding of human health and medicine? This enigma continues to drive research and spark debates in the medical and historical communities. Ancient cultures developed their knowledge of medicinal plants through centuries of observation, trial and error, and passed down wisdom. They closely watched how animals interacted with plants, noting which ones they ate when sick. This animal behavior provided valuable clues about potential healing properties. Healers and shamans in these societies conducted extensive experimentation, carefully documenting the effects of different plants on various ailments. They developed complex systems of categorizing plants based on their tastes, smells, and physical characteristics, which often correlated with their medicinal uses. Traditional knowledge was preserved and refined through oral traditions, with information passed from one generation to the next. This accumulation of experience over thousands of years led to a deep understanding of plant properties, even without modern scientific methods. Many ancient cultures also believed in the doctrine of signatures, which suggested that plants resembling certain body parts could be used to treat ailments in those areas. While not always accurate, this belief sometimes led to the discovery of genuinely effective treatments. Archaeological discoveries have revealed fascinating evidence of ancient Maya medical practices, including successful brain surgeries. Excavations at various Maya sites have unearthed skulls with precise rectangular holes that show signs of healing. These findings indicate that the individuals survived the procedures, sometimes for years after the surgery. The Maya used obsidian blades, incredibly sharp volcanic glass tools, to perform these delicate operations. These blades were capable of making clean, precise cuts, which were crucial for the success of such intricate procedures. The skill required to perform these surgeries suggests a sophisticated understanding of anatomy and medical techniques among Maya healers. One particularly notable example comes from the archaeological site of Palenque in Mexico. A skull found there displays evidence of trepanation, a surgical technique involving the removal of a section of the skull. The smooth edges of the hole and signs of bone regrowth indicate that the patient survived the procedure and lived for a considerable time afterward. Additionally, Maya codices and other historical records mention treatments for head injuries and brain-related ailments, further supporting the idea that they possessed advanced medical knowledge. These findings challenge our perceptions of ancient medical practices and highlight the remarkable achievements of Maya civilization in the field of medicine. Ancient healers across different cultures often stumbled upon similar remedies through a combination of careful observation, trial and error, and the passing down of knowledge through generations. This convergence of healing practices can be attributed to the universal nature of human physiology and the common ailments that affect people worldwide. One key factor was the abundance of certain plants with medicinal properties in multiple regions. For instance, willow bark, which contains salicylic acid, a precursor to aspirin, was used by healers in ancient Egypt, Greece, and Native American cultures to treat pain and fever. The effectiveness of these plants led to their continued use and refinement over time. Additionally, ancient healers were keen observers of nature and animal behavior. They noticed how certain animals sought out specific plants when ill, leading them to experiment with these plants for human use. This observational approach, combined with the gradual accumulation of knowledge about which treatments worked and which did not, resulted in a body of effective remedies that were surprisingly similar across cultures. Furthermore, the basic principles of balance and harmony in the body, though expressed differently in various traditions, often led to comparable treatments. Whether it was the concept of humors in Greek and Roman medicine, or the balance of yin and yang in traditional Chinese medicine, these underlying philosophies guided healers towards similar conclusions about maintaining health and treating illness. The Edwin Smith Papyrus stands as a cornerstone in our understanding of ancient Egyptian medical practices. This remarkable document, dating back to around 1600 BCE, provides unprecedented insight into the sophisticated medical knowledge of the ancient Egyptians. Unlike other medical texts from this era, the Edwin Smith Papyrus focuses primarily on traumatic injuries, detailing 48 case studies with a level of precision that was far ahead of its time. It describes symptoms, examinations, diagnoses, and treatments for various conditions, particularly those affecting the head, neck, and upper body. What sets this papyrus apart is its rational, scientific approach to medicine. It largely eschews magical remedies and incantations, instead relying on observable symptoms and physical examinations. This approach mirrors modern medical practices in many ways, showcasing the advanced state of Egyptian medicine over 3.5 millennia ago. The papyrus also provides evidence of early neuroscience, including the first known descriptions of the brain, spinal cord, and cerebrospinal fluid. It even recognizes the impact of brain injuries on bodily functions, a concept that would not be fully understood in Western medicine for thousands of years. This ancient text continues to amaze modern medical professionals, serving as a testament to the ingenuity and observational skills of ancient Egyptian physicians. Ancient cultures across the world developed various methods to manage pain and induce unconsciousness during medical procedures, despite lacking modern pharmacological knowledge. These early anesthetics often relied on naturally occurring substances and time-tested techniques passed down through generations. One of the most common ancient anesthetics was alcohol, particularly wine. Civilizations from Egypt to China used alcohol to dull pain and relax patients before surgeries. In some cases, they combined alcohol with other substances like opium or mandrake root to enhance its sedative effects. Plant-based remedies played a crucial role in early anesthesia. The Incas, for instance, chewed coca leaves to produce a numbing effect for trephination, a procedure involving drilling holes in the skull. In India, physicians used cannabis and henbane to induce sleep and reduce pain. Ancient Egyptians applied a mixture of limestone and vinegar to surgical sites, creating a reaction that released carbon dioxide and provided local anesthesia. Some cultures employed physical techniques alongside these substances. Compression of blood vessels or nerves, rapid spinning to induce dizziness, and even controlled bleeding were used to render patients unconscious or less sensitive to pain. While these methods were far from perfect and often dangerous by modern standards, they demonstrate the ingenuity of ancient healers in addressing the challenges of surgical pain. Ancient civilizations demonstrated a remarkable understanding of antiseptic principles even without modern scientific knowledge. The Egyptians, for instance, used honey as a wound dressing, which we now know has natural antibacterial properties. They also employed molds and fungi in treating infections, foreshadowing the discovery of penicillin by thousands of years. In ancient Greece, Hippocrates recommended the use of vinegar and wine to clean wounds, both of which have antiseptic qualities. He also advised surgeons to use only clean water and wine to wash their hands before procedures, an early form of surgical sterilization. The Romans continued this tradition, using silver vessels to store water and wine, unknowingly benefiting from silver's antimicrobial properties. They also developed complex systems of aqueducts and sewers, demonstrating an understanding of the importance of sanitation in preventing disease. In ancient China, traditional healers used various herbs with known antiseptic properties, such as garlic and ginger, in their medical practices. These early applications of antiseptic principles, while not based on germ theory, show that ancient practitioners recognized the importance of cleanliness and certain substances in preventing infection and promoting healing. Ancient healers, particularly in India, developed remarkable techniques for cataract surgery thousands of years ago. Their method, known as couching, involved using a specially curved needle to push the cloudy lens of the eye downward, clearing the path for light to enter. This procedure, while primitive by today's standards, often restored some vision to patients who would otherwise have been blind. These early surgeons possessed an impressive understanding of eye anatomy, despite lacking modern medical knowledge. They recognized that the cataract was a physical obstruction that could be moved rather than a supernatural affliction. Their tools, though simple, were carefully crafted for the task. The needles were often made of copper or bronze and were surprisingly well suited for the delicate work of eye surgery. The ancient healers also employed natural substances as rudimentary anesthetics and antiseptics. Preparations made from plants like cannabis and henbane were used to dull pain, while herb-infused waters helped prevent infections. These early medicinal practices, combined with the surgical technique, contributed to the success of these procedures. It is important to note that while these surgeries were sometimes successful, they were also risky. Complications such as infections were common, and the results were far from guaranteed. Nevertheless, the existence of such advanced surgical techniques in ancient times demonstrates the ingenuity and skill of early medical practitioners in addressing complex health issues with limited resources. Ancient metallurgists developed remarkable techniques for creating rust-resistant iron pillars, showcasing their advanced understanding of materials science. One of the most famous examples is the Iron Pillar of Delhi, which has stood for over 1,500 years with minimal corrosion. The secret to this pillar's longevity lies in its unique composition and manufacturing process. Ancient Indian metalworkers created a high-phosphorus iron alloy, which forms a protective layer when exposed to air. This layer, composed of iron, oxygen, and phosphorus compounds, acts as a barrier against further corrosion. Additionally, these craftsmen employed a technique called hot forging, where the iron was repeatedly heated and hammered. This process helped to distribute the phosphorus evenly throughout the metal, enhancing its protective properties. The pillar was also constructed in a single piece, eliminating weak points where rust could take hold. Other ancient cultures, such as the Chinese, developed their own methods for creating durable iron structures. They used techniques like quenching, where hot metal is rapidly cooled, and alloying iron with other elements to improve its resistance to corrosion. These advancements in metallurgy demonstrate the sophisticated scientific knowledge of our ancestors. Damascus steel, renowned for its distinctive wavy pattern and exceptional strength, has long captivated metallurgists and historians alike. This legendary metal, used in the creation of formidable swords, originated in the Near East during the Middle Ages. Its production method remained a closely guarded secret for centuries, eventually becoming lost to time. The unique properties of Damascus steel stem from its composition and forging process. It is believed that the steel was made using woots, a type of crucible steel from India, which contained trace elements such as vanadium, chromium, manganese, and niobium. These elements, combined with a specific heat treatment and forging technique, resulted in the formation of carbon nanotubes and carbide nanowires within the steel's structure. The mystery deepened when the production of true Damascus steel ceased around the 18th century. Theories suggest that the loss of the technique could be attributed to the exhaustion of the specific ore used, changes in trade routes, or the guarding of the secret by a small group of craftsmen who failed to pass on their knowledge. Modern attempts to recreate Damascus steel have yielded similar-looking products, but none have fully replicated the original's remarkable combination of flexibility, hardness, and sharpness. The elusive nature of its creation continues to inspire scientific research and capture the imagination of blacksmiths and materials scientists, making Damascus steel an enduring metallurgical enigma. Ancient Egyptian metalworkers were masters of their craft, developing sophisticated techniques to create durable copper alloys that have stood the test of time. Their expertise in metallurgy allowed them to produce tools, weapons, and decorative objects that remain impressive to this day. The key to their success lay in their ability to combine copper with other metals, particularly tin and arsenic. By adding small amounts of these elements to copper, Egyptian craftsmen created bronze alloys that were significantly harder and more resistant to corrosion than pure copper. This process, known as alloying, transformed the soft, malleable copper into a much more durable material. Egyptian metalworkers also employed advanced smelting and casting techniques. They used high-temperature furnaces to extract copper from its ore and carefully controlled the cooling process to achieve desired properties in the final product. The craftsmen would often work the metal through repeated heating and hammering, a process that further increased its strength and durability. Furthermore, Egyptian metalworkers developed specialized tools and techniques for shaping and finishing their copper alloys. They used stone and bronze tools to cut, shape, and polish their creations, often adding intricate designs and engravings. This attention to detail, combined with their metallurgical knowledge, resulted in copper alloy artifacts that have endured for thousands of years, providing us with valuable insights into ancient Egyptian technology and craftsmanship. Archaeological findings have revealed surprising evidence of advanced metalworking techniques in ancient civilizations. Excavations at sites dating back thousands of years have uncovered artifacts that required temperatures far beyond what was previously thought possible for those times. For instance, ancient Egyptian craftsmen produced intricate gold objects with complex designs, indicating they could reach temperatures high enough to melt and work with this precious metal. Even more impressive are discoveries related to iron smelting. Ancient iron artifacts from various cultures show sophisticated metallurgical knowledge. The production of high-quality steel, found in some ancient weapons and tools, requires temperatures of over 1,400 degrees Celsius. Achieving and controlling such high temperatures was a remarkable feat for ancient metalworkers, considering the limitations of their technology. Archaeologists have also found evidence of specialized furnaces and crucibles designed to withstand extreme heat. These structures, made from materials like clay and specific types of stone, could maintain the intense temperatures needed for advanced metalworking. The presence of slag, a byproduct of metal smelting, at many ancient sites further supports the idea that these cultures had mastered high-temperature processes. The ability to work with metals at such high temperatures had profound implications for ancient societies. It allowed for the creation of stronger tools, more effective weapons, and intricate jewelry. This technological prowess likely contributed to the rise and dominance of certain civilizations, shaping the course of human history and laying the groundwork for future metallurgical advancements. The creation of advanced platinum alloys by pre-Columbian cultures in South America is a remarkable achievement that continues to intrigue scientists and historians. These ancient metallurgists, particularly those of the La Tolita culture in present-day Ecuador, developed sophisticated techniques to work with platinum, a metal that requires extremely high temperatures to melt. The key to their success lay in a process called sintering. Instead of trying to melt pure platinum, which has a melting point of over 3,000 degrees Celsius, these skilled craftsmen mixed platinum grains with gold dust. When heated, the gold would melt and flow between the platinum particles, effectively binding them together. This ingenious method allowed them to create alloys and craft intricate objects without the need for modern high-temperature furnaces. Furthermore, these ancient metallurgists discovered that by repeatedly heating and hammering the platinum-gold mixture, they could gradually increase the platinum content of their alloys. This process, known as depletion gilding, involved the gold slowly migrating to the surface where it could be removed, leaving behind a more platinum-rich alloy. What makes this technological feat even more impressive is that it predates European understanding of platinum by over 1,000 years. The Spanish conquistadors, upon encountering platinum in South America, initially dismissed it as an inferior metal they called platina, or little silver. It would take European scientists centuries to match the level of platinum craftsmanship achieved by these ancient South American cultures. The advanced metallurgy found in ancient Indian temples is a testament to the remarkable scientific and technological achievements of early Indian civilizations. These metalworking techniques, some dating back over 2,000 years, demonstrate a level of sophistication that was far ahead of its time. One of the most famous examples is the Iron Pillar of Delhi, a massive column standing over 7 meters tall and weighing more than 6 tons. This pillar, created around the 4th century CE, has remained rust-free for over 1,600 years, showcasing an exceptional understanding of corrosion-resistant iron production. The exact method used to create this pillar remains a subject of scientific inquiry and admiration. Many ancient Indian temples also feature intricate bronze statues and ornaments, created using the lost wax casting technique. This method allowed artisans to produce complex, detailed sculptures with a level of precision that was unparalleled in the ancient world. The Nataraja statue at the Chidambaram temple, depicting the Hindu god Shiva as the cosmic dancer, is a prime example of this advanced bronze casting technique. The metallurgical expertise evident in these temples extends beyond aesthetics. It includes the use of iron beams and joints in temple construction, which have withstood earthquakes and harsh weather conditions for centuries. This advanced knowledge of metals and their properties not only contributed to the longevity of these structures, but also reflects the deep scientific understanding possessed by ancient Indian civilizations, challenging our perceptions of technological progress in the ancient world. Ancient cultures did not actually discover or refine aluminum in the way we might assume. Aluminum, despite being the 3rd most abundant element in Earth's crust, was not isolated as a pure metal until the 19th century. This is because aluminum does not occur naturally in its pure form and is always found combined with other elements, most commonly in a mineral called bauxite. The ancient Persians and Romans used a compound called alum, which contains aluminum, but they did not recognize it as a distinct element. Alum was used for dyeing fabrics and as a medicinal astringent. However, these early civilizations had no concept of aluminum as we know it today. The first person to produce aluminum metal was Hans Christian Ørsted in 1824, but his sample was impure. It was not until 1827 that Friedrich Wöhler created the first pure aluminum samples. Even then, aluminum remained extremely rare and valuable for decades. In fact, aluminum was once considered more precious than gold or silver due to the difficulty of extracting it from its ore. The modern method of aluminum production, known as the Hall-Héroult process, was not developed until 1886. This electrolytic process made large-scale aluminum production possible and transformed it from a precious metal to a common material used in countless applications today. Archaeologists have uncovered intriguing artifacts that hint at the possibility of ancient civilizations possessing knowledge of electroplating. One of the most compelling pieces of evidence is the Baghdad battery, discovered in Iraq and dating back to the Parthian period, around 2,000 years ago. This curious object consists of a clay jar containing a copper cylinder and an iron rod, which some researchers believe could have been used as a primitive galvanic cell. While the exact purpose of the Baghdad battery remains debated, experiments have shown that it could produce a small electrical current when filled with an acidic liquid like vinegar or wine. This has led some scientists to speculate that ancient artisans might have used similar devices for electroplating, a process that deposits a thin layer of metal onto another surface using electricity. Further evidence comes from ancient Egyptian artifacts that exhibit unusually thin and uniform gold coatings. Traditional gilding techniques of the time typically resulted in thicker, less even layers. The precision and consistency of these coatings have led some experts to propose that the Egyptians might have developed a form of electroplating, although this remains a topic of ongoing research and debate. It is important to note that while these findings are fascinating, they do not conclusively prove that ancient civilizations fully understood or widely practiced electroplating. However, They do suggest that our ancestors may have stumbled upon or developed rudimentary forms of electrical technology, opening up new avenues for exploration in the field of ancient technological achievements. Ancient metallurgists were masters of their craft, relying on keen observation, experience, and techniques passed down through generations. They developed sophisticated methods to create precise alloys without the benefit of modern measuring tools. One key approach was the use of color as an indicator. Different metals and alloys have distinct hues, and skilled metalworkers could judge the composition of a mixture by its precise shade. For instance, they knew that adding a specific amount of tin to copper would result in a particular color of bronze. Another technique involved observing the behavior of the molten metal. The way it flowed, its viscosity, and how it reacted when poured into molds all provided valuable information about its composition. Metallurgists also used the sound of the metal as it cooled and solidified as a clue to its makeup. Furthermore, ancient craftsmen employed test pieces and trial and error to refine their alloys. They would create small samples, test their properties, and adjust the mixture accordingly. This iterative process, combined with their deep understanding of how different metals interacted, allowed them to achieve remarkable precision in their final products. Ancient Roman concrete has puzzled scientists for centuries due to its remarkable durability and resistance to heat. Unlike modern concrete, which can deteriorate within decades, Roman concrete structures have withstood the test of time for over 2,000 years. The secret lies in its unique composition and an unexpected chemical reaction that occurs over time. The Romans used a mixture of volcanic ash, lime, and seawater to create their concrete. This combination results in the formation of rare minerals that are not typically found in modern concrete. One of these minerals, aluminum tobermarite, actually grows stronger when exposed to seawater, explaining why many Roman marine structures remain intact to this day. Recent studies have revealed that the heat-resistant properties of Roman concrete are due to a phenomenon called hot mixing. The ancient Romans would mix quicklime with water and volcanic rock at high temperatures, creating a chemical reaction that formed calcium aluminum silicate hydrate. This compound fills tiny cracks in the concrete as they form, making the material self-healing and incredibly resistant to heat and water damage. This self-healing property is what gives Roman concrete its exceptional longevity and heat resistance. As the concrete ages, it becomes stronger and more durable, a characteristic that modern concrete lacks. Scientists are now working to replicate this ancient formula, hoping to create more sustainable and long-lasting building materials for the future. The ancient Egyptians employed ingenious methods to transport colossal stone blocks for pyramid construction, showcasing their advanced engineering skills. They primarily used a combination of sleds, ramps, and levers to move these massive stones from quarries to construction sites. Wooden sleds were crucial in this process. The Egyptians would place stone blocks on these sleds and pull them across the desert. To reduce friction and make the journey easier, they would wet the sand in front of the sled. This technique significantly decreased the force required to move the heavy loads, allowing smaller teams to transport larger stones. For uphill transportation, the Egyptians constructed long, gently sloping ramps. These ramps, made from limestone chips, clay, and wood, allowed workers to drag the stone blocks up the pyramid as it was being built. The ramps were likely spiral in shape, wrapping around the pyramid as it grew taller, though some theories suggest straight ramps or a combination of both designs. In addition to sleds and ramps, the Egyptians used levers and rockers to maneuver stones into place. These simple machines allowed workers to lift and position the massive blocks with remarkable precision. The entire process required immense coordination and planning, demonstrating the sophisticated organizational skills of ancient Egyptian society. Ancient cultures around the world developed ingenious methods to move and erect massive stone statues, showcasing their engineering prowess and determination. In Easter Island, the Rapa Nui people used a combination of wooden rollers, sleds, and ropes to transport their iconic Moai statues. They would carve the statues while they were still attached to the quarry, then carefully tilt and lower them onto wooden sleds. Teams of workers would then pull the sleds using ropes made from local plants, while others placed round logs underneath to act as rollers. The ancient Egyptians employed similar techniques to move the colossal statues found in their temples and monuments. They created smooth, lubricated surfaces using wet clay or sand, allowing massive stone blocks to slide more easily. Ramps were constructed to help workers pull the statues up inclines, often using a system of levers and counterweights to assist in the process. In South America, the Olmec civilization transported enormous basalt heads weighing up to 40 tons across challenging terrain. They likely used a combination of log rollers, sleds, and temporary wooden trackways to move these monumental sculptures. The Olmecs may have also taken advantage of river systems, floating the statues on rafts when possible to reduce the distance they needed to be transported over land. Once at their final locations, these ancient cultures used a variety of methods to erect the statues. Some employed earthen ramps that were gradually built up around the statue as it was raised. Others used a system of levers and pulleys to slowly tilt the statue upright. The specific techniques varied depending on the size and shape of the statue, as well as the local resources and terrain. Pre-Columbian civilizations developed ingenious methods to transport materials across challenging terrains. The Inca, for instance, constructed an extensive network of roads spanning over 39,000 kilometers through the Andes Mountains. These roads facilitated the movement of goods and people across steep slopes and high altitudes. One of the most remarkable transport methods was the use of human porters called chasquis. These highly trained runners could cover great distances quickly, relaying messages and small valuable items across the empire. For heavier loads, the Inca utilized llamas as pack animals, capable of carrying up to 45 kilograms of goods through rugged mountain passes. In Mesoamerica, the Maya and Aztec civilizations faced different challenges, including dense jungles and swampy terrain. They often relied on canoes to navigate intricate river systems, transporting goods between cities and trading centers. On land, they developed a system of well-maintained footpaths and hired porters to carry goods in backpacks called tumplines. The ancient city of Teotihuacan in central Mexico showcases another innovative solution. Archaeologists have discovered a system of underground tunnels beneath the city, which may have been used to transport materials for construction and trade, allowing for efficient movement without the need to navigate the crowded streets above. Ancient civilizations demonstrated remarkable ingenuity when it came to moving massive objects, and evidence suggests they had sophisticated knowledge of friction reduction techniques. In Egypt, for instance, archaeologists have discovered remnants of wooden sleds used to transport enormous stone blocks for pyramid construction. These sleds were placed on prepared paths moistened with water, creating a slippery surface that significantly reduced friction. Similarly, in ancient Mesopotamia, cylinder seals depict large statues being transported on sleds, with liquid poured in front to lubricate the path. This method was not limited to the Middle East. Evidence from Easter Island suggests that the massive Moai statues were transported using a rocking motion on wooden rollers, effectively minimizing ground contact and friction. Perhaps most intriguing is the recent discovery at the Forbidden City in Beijing. Researchers found that the ancient Chinese used an intricate ice road system to transport enormous stones, some weighing over 100 tons. They would dig wells every 500 meters along the route, using the water to create smooth ice paths in winter. This method reduced friction to a level comparable to modern lubricated surfaces, allowing for the efficient transport of massive loads over long distances. These examples highlight the advanced understanding our ancestors had of friction reduction principles, demonstrating that complex engineering concepts were not exclusive to modern times. Their innovative solutions to seemingly insurmountable challenges continue to astound scientists and engineers today. Ancient cultures developed impressive road networks through a combination of ingenuity, engineering skill, and sheer determination. The Romans, for example, were master road builders who constructed over 50,000 miles of paved roads across their vast empire. They used sophisticated surveying techniques to ensure their roads were straight and level, often cutting through hills and bridging valleys to maintain a direct route. These ancient engineers employed a layered construction method, starting with a solid foundation of packed earth and gravel. They then added layers of larger stones, followed by a surface of tightly fitted paving stones. This technique created durable roads that could withstand heavy traffic and harsh weather conditions for centuries. In South America, the Inca built an extensive network of roads spanning nearly 25,000 miles across challenging mountain terrain. They carved steps into steep hillsides and constructed impressive rope bridges to cross deep gorges. The Inca also developed a sophisticated system of runners called chasqui, who could relay messages across vast distances with remarkable speed. Other ancient cultures, such as the Persians and Chinese, also created extensive road networks that facilitated trade, communication, and military movements. These transportation systems were often so well designed and constructed that many of their routes are still in use today, testament to the skill and foresight of these ancient builders. Ancient seafarers developed ingenious methods for navigating vast oceans without modern technology. One of the most common techniques was celestial navigation, where sailors used the positions of stars, the sun, and other celestial bodies to determine their location and direction. The North Star, Polaris, was particularly important for sailors in the Northern Hemisphere, as it remains fixed in the night sky and indicates true north. Polynesian navigators mastered a technique called wayfinding, which combined observations of stars, ocean swells, cloud formations, and wildlife patterns to navigate across the Pacific. They created stick charts to map ocean currents and wave patterns using an intricate system of knowledge passed down through generations. In the Mediterranean, ancient mariners often practiced coastal navigation, sailing within sight of land and using landmarks to guide their journey. They also relied on sounding weights to measure water depth and detect nearby land. The Vikings used a combination of these methods, along with primitive sundials and their deep understanding of prevailing winds and currents. Some cultures even developed early nautical instruments. The kamal, used by Arab navigators, was a rectangular wooden card with a string that helped determine latitude by measuring the angle between the horizon and celestial bodies. These diverse navigation methods allowed ancient civilizations to explore, trade, and connect across vast distances, laying the groundwork for our modern understanding of global geography. The development of the wheel across different ancient cultures is a fascinating example of parallel innovation. Societies around the world, from Mesopotamia to China and from Europe to Mesoamerica, all arrived at similar wheel designs independently. This convergence occurred because the wheel is a fundamental solution to the universal challenge of efficiently moving heavy loads. The basic principle of the wheel, a circular object that rotates around an axle, is rooted in the observation of natural phenomena. Rolling logs or round stones likely inspired early humans to consider circular motion for transportation. As societies grew more complex and the need for transporting goods increased, the concept of the wheel naturally evolved. The similar designs that emerged can be attributed to the inherent efficiency of the circular shape. A well-balanced circular wheel distributes weight evenly and reduces friction, making it the most effective shape for smooth rotation. This optimal design was discovered through trial and error in various cultures, leading to remarkably similar outcomes. It's important to note that while the basic wheel concept was similar, there were regional variations in materials and construction methods. Some cultures used solid wooden discs, while others developed spoked wheels. These differences reflect the available resources and specific needs of each society, showcasing how universal principles can be adapted to local conditions. archaeological discoveries and ancient texts provide intriguing evidence that several ancient civilizations possessed knowledge of complex pulley systems. In ancient Egypt, hieroglyphs and wall paintings depict the use of rope and pulley mechanisms for construction projects, particularly in the building of pyramids and temples. These images show workers using ropes looped around stone blocks, suggesting a rudimentary understanding of mechanical advantage. The ancient Greeks made significant advancements in pulley technology. Archimedes, the renowned mathematician and inventor, is credited with developing the compound pulley system in the 3rd century BCE. Historical accounts describe his demonstration of a complex pulley system that allowed him to single-handedly move a fully loaded ship, showcasing the immense power of this technology. In Mesopotamia, cuneiform tablets from as early as 2000 BCE describe the use of pulleys in irrigation systems and construction. These texts detail methods for lifting heavy objects and moving water, indicating a sophisticated grasp of mechanical principles. Similarly, ancient Chinese texts from the Warring States period mention the use of pulley systems in well construction and for military applications, such as siege engines. The Roman architect Vitruvius, writing in the 1st century BCE, provided detailed descriptions of various pulley systems used in construction and engineering projects throughout the Roman Empire. His work demonstrates that by this time, complex pulley systems were well understood and widely implemented in large-scale engineering endeavors. Ancient cultures developed remarkably effective land surveying techniques for road building through a combination of practical experience, mathematical knowledge, and ingenious tools. The Romans, for instance, were masters of road construction, creating a vast network that spanned their empire. They employed skilled agrimensors or land surveyors who used sophisticated instruments like the groma and chorobads to ensure accurate measurements and proper grading of roads. The groma was a simple yet precise tool consisting of a vertical staff with horizontal crosspieces. Surveyors used it to create straight lines and right angles, essential for laying out roads across varied terrain. The chorobads, a long wooden bench with plumb lines, allowed surveyors to determine level surfaces and calculate gradients, crucial for proper water drainage on roads. These ancient surveyors also relied heavily on geometry and trigonometry. They understood the principles of triangulation, using known distances and angles to calculate unknown distances. This knowledge enabled them to plan routes efficiently, even in challenging landscapes. Additionally, they used the concept of sightlines, establishing a series of elevated points to maintain a straight path over long distances. Ancient cultures in other parts of the world developed their own surveying methods. The Incas, for example, created an extensive road system in the challenging terrain of the Andes Mountains. They used a system of knotted cords called quipu to record distances and elevations, demonstrating that effective surveying techniques could be developed even without written language or advanced mathematical notation. Ancient civilizations developed remarkable techniques for precise weight distribution in their monumental structures, showcasing ingenuity that continues to impress modern engineers. One of the most notable methods was the use of corbelling, a technique where successive layers of stone are placed with each course extending slightly beyond the one below. This allowed ancient builders to create structures that gradually narrowed towards the top, effectively distributing the weight and preventing collapse. The ancient Egyptians, masters of colossal construction, employed sophisticated methods in building their pyramids. They used a system of ramps and levers to move massive stone blocks into place, ensuring even weight distribution throughout the structure. Additionally, they incorporated internal chambers and passages, which not only served functional purposes, but also helped to reduce the overall mass of the pyramid. In ancient Greece and Rome, architects utilized the principle of the arch to distribute weight effectively. Arches allowed for the creation of large open spaces while transferring the load to supporting columns or walls. This technique was further refined with the development of vaulted ceilings and domes, which distributed weight across a wider area. The Incan civilization in South America perfected the technique of precision stone fitting. Their structures featured large, interlocking stone blocks cut to fit together so tightly that even a knife blade could not be inserted between them. This method ensured excellent weight distribution and stability, allowing their buildings to withstand centuries of earthquakes and other natural forces. The ancient Egyptians were masters of creating vibrant and enduring pigments that have stood the test of time. Their secret lay in their ingenious use of naturally occurring minerals and their advanced knowledge of chemistry. One of the most iconic Egyptian pigments was Egyptian blue, a synthetic color created by heating a mixture of silica, lime, copper, and alkali. This process produced a brilliant blue pigment that has remained stable for thousands of years. The Egyptians also extracted pigments from minerals such as malachite for green, ochre for yellows and reds, and carbon for black. To ensure the longevity of their pigments, ancient Egyptians often mixed them with binders such as egg whites, gum arabic, or beeswax. These organic binders not only helped the pigments adhere to surfaces, but also protected them from environmental factors. Additionally, the dry climate of Egypt played a crucial role in preserving these colors, as moisture is often a destructive force for pigments. The Egyptians' meticulous preparation techniques and their understanding of material properties allowed them to create pigments that have retained their vibrancy for millennia. Their legacy continues to amaze us, offering glimpses into a colorful past that has refused to fade. Maya blue is an extraordinary pigment that has puzzled scientists for decades. This vibrant blue color, used by the ancient Maya civilization, has shown remarkable resistance to degradation over centuries. Unlike many other pigments from antiquity, Maya blue retains its brilliance and does not fade, even when exposed to harsh environmental conditions. The secret behind the durability of Maya blue lies in its unique composition. It is not a simple mixture, but a complex hybrid material. The pigment is created by combining indigo, a natural blue dye extracted from the leaves of the annual plant, with a special type of clay called palygorskite. When these components are heated together, they form a stable compound that is incredibly resistant to weathering, acids, and even modern solvents. What makes Maya blue truly remarkable is the way the indigo molecules become embedded within the lattice structure of the clay. This integration occurs at the nanoscale level, creating a material that is more than the sum of its parts. The result is a pigment that can withstand centuries of exposure to the elements, retaining its color and integrity in a way that few other ancient pigments can match. The discovery of how Maya blue was made has implications beyond art history. Understanding the chemistry behind this durable pigment could lead to the development of new, long-lasting colorants for modern applications. The ingenuity of the ancient Maya in creating this enduring blue continues to inspire scientists and artists alike, bridging the gap between ancient wisdom and contemporary innovation. Ancient cultures developed remarkably effective waterproofing techniques using natural materials available to them. One of the most widely used substances was bitumen, a naturally occurring form of petroleum. This thick, sticky material was abundant in regions like Mesopotamia and was applied to boats, buildings, and even used in mummification processes in ancient Egypt. The Romans made significant advancements in waterproofing technology. They created a substance called opus signinum, a mixture of lime mortar, crushed ceramics, and sometimes volcanic ash. This material was used to line aqueducts, cisterns, and baths, providing an impressively durable and water-resistant surface. In Central and South America, ancient civilizations like the Maya used natural latex from rubber trees to create waterproof coatings. They applied this substance to fabrics and other materials to protect them from rain and moisture. Similarly, many cultures used animal fats and oils to treat leather and fabrics, creating water-resistant clothing and shelter materials. Indigenous peoples in various parts of the world developed plant-based waterproofing methods. For example, some Native American tribes used pine resin to seal canoes and create watertight containers. These natural solutions, while simple, proved highly effective and demonstrate the ingenuity of ancient peoples in working with their environment to solve practical problems. Ancient civilizations demonstrated remarkable knowledge of complex chemical reactions, far beyond what many might expect. The Egyptians, for instance, were masters of metallurgy, creating intricate alloys and developing sophisticated techniques for extracting and purifying gold. Their understanding of chemical processes allowed them to produce vibrant pigments that have endured for millennia in their tomb paintings. In Mesopotamia, the Babylonians developed advanced glass-making techniques, combining various minerals and compounds to create colored glass as early as 1800 BCE. This process required a nuanced understanding of how different elements interact when heated to extreme temperatures. The ancient Chinese were pioneers in the field of gunpowder, mixing precise ratios of potassium nitrate, charcoal, and sulfur to create explosives. This discovery, made around 800 CE, showcases a deep comprehension of chemical reactions and their potential applications. Perhaps most intriguing is the mysterious Greek fire, a combustible liquid weapon used by the Byzantine Empire. Its exact composition remains unknown, but its creation and use indicate a sophisticated grasp of chemical properties and reactions. These examples illustrate that ancient civilizations possessed far more advanced chemical knowledge than often credited, paving the way for modern scientific understanding. Ancient alchemists played a crucial role in the discovery and refinement of metals, laying the groundwork for modern metallurgy. Their methods, while primitive by today's standards, were groundbreaking for their time and often involved a combination of observation, experimentation, and mystical beliefs. These early practitioners began by identifying naturally occurring metals like gold, silver, and copper. They learned to extract these metals from ores through heating and smelting processes. By observing how different materials reacted to heat and various substances, alchemists gradually developed more sophisticated techniques for purifying and working with metals. One of the most significant contributions of ancient alchemists was the discovery of mercury and its unique properties. They found that mercury could dissolve other metals, particularly gold, leading to its use in gold extraction and purification. This process, known as amalgamation, remained a key method in gold refining for centuries. Alchemists also made strides in creating alloys, combining different metals to produce materials with new properties. Bronze, an alloy of copper and tin, was one of the earliest and most important discoveries, ushering in the Bronze Age and revolutionizing tool-making and weaponry. These early experiments with metals not only advanced practical knowledge, but also fueled the alchemist's quest for the legendary philosopher's stone and the transmutation of base metals into gold. The advanced chemical knowledge found in ancient Chinese texts is a testament to the remarkable scientific achievements of early Chinese civilization. These texts, some dating back over 2,000 years, reveal a sophisticated understanding of chemical processes that were far ahead of their time. Chinese alchemists and scholars had developed complex techniques for extracting and purifying various substances, including metals and minerals. They were particularly adept at creating alloys and understood the properties of different materials at a level that wouldn't be matched in the Western world for centuries. One of the most significant aspects of this ancient knowledge was its practical applications. Chinese texts describe methods for creating gunpowder, which would later revolutionize warfare globally. They also detail processes for producing medicines, dyes, and other useful compounds that improved daily life and contributed to technological advancements. This early mastery of chemistry not only shaped Chinese culture and technology, but also influenced scientific development across Asia and eventually the world. The preservation of this knowledge in ancient texts provides invaluable insights into the intellectual capabilities of our ancestors and highlights the importance of cross-cultural scientific exchange throughout history. Ancient cultures developed remarkably effective adhesives and mortars through ingenious use of natural materials and keen observation of their properties. The Egyptians, for instance, created a lime mortar by burning limestone to produce quicklime, which was then mixed with water and sand. This mixture would slowly absorb carbon dioxide from the air, hardening into a durable cement that has lasted for millennia. In Mesoamerica, the Maya developed an advanced form of concrete by combining limestone with tree resins and plant extracts. This mixture was not only strong, but also resistant to the region's humid climate. The Romans took mortar technology even further by adding volcanic ash to their lime mixtures, creating a hydraulic cement that could set under water and withstand the test of time. For adhesives, many ancient cultures used natural substances like tree resins, animal glues, and plant-based materials. The Aztecs, for example, used an adhesive made from orchid bulbs to attach feathers to their ceremonial headdresses. This glue was so effective that these delicate artifacts have survived for centuries. These ancient adhesives and mortars demonstrate the innovative spirit of our ancestors. Through trial and error and careful observation of the natural world, they created binding materials that have stood the test of time, some even outperforming modern alternatives in terms of longevity and durability. Archaeological findings and historical records provide intriguing clues about ancient civilizations' understanding of catalysts, even if they didn't use that specific term. The Egyptians, for instance, used natron, a naturally occurring mixture of sodium compounds, in their mummification process. This substance acted as a drying agent and helped preserve organic matter, demonstrating an early grasp of chemical reactions and their acceleration. In ancient Mesopotamia, beer brewers utilized specially prepared clay tablets to speed up fermentation. These tablets, now understood to contain enzymes and microorganisms, effectively served as catalysts in the brewing process. This suggests that while the Mesopotamians might not have fully comprehended the underlying science, they recognized that certain substances could enhance and accelerate desired chemical changes. Chinese alchemists in the 4th century BCE documented the use of mercury and other substances to facilitate the transformation of base metals. Although their ultimate goal of creating gold was unattainable, their experiments revealed an understanding that some materials could influence chemical reactions without being consumed in the process, a key characteristic of catalysts. The ancient Greeks also demonstrated knowledge of catalytic processes. Aristotle observed that rust formation on iron could be accelerated by the presence of certain substances. While he lacked the modern scientific framework to explain this phenomenon, his observations laid groundwork for future understanding of oxidation reactions and catalysis. Ancient cultures across the world developed an impressive array of dyes from natural sources through centuries of experimentation and observation. These vibrant colors were extracted from plants, animals, and minerals found in their local environments. Plant-based dyes were among the most common and diverse. Roots, leaves, bark, and flowers all provided unique hues. For example, the indigo plant yielded a deep blue, while madder root produced rich reds. Yellow came from saffron and turmeric, and green from various leaves and grasses. Indigenous peoples in the Americas used cochineal insects to create vivid scarlet dyes, a technique later adopted by European traders. Mineral-based dyes also played a crucial role. Ochre, a naturally occurring pigment containing iron oxide, provided earthy reds and yellows. Lapis lazuli, ground into a fine powder, created a prized blue pigment. Some cultures even developed complex processes to create dyes from metals like copper and iron. The development of these dyes required not only identifying suitable sources, but also perfecting extraction and application methods. Cultures passed down this knowledge through generations, refining techniques and expanding their color palettes. This rich history of natural dyes demonstrates the ingenuity and resourcefulness of ancient peoples in their quest to bring color to their world. Ancient civilizations developed various ingenious methods for water purification, recognizing the vital importance of clean water for their survival and health. The Egyptians, as early as 4,000 years ago, used the process of coagulation. They added alum, a type of mineral salt, to water, which caused suspended particles to clump together and settle at the bottom, leaving clearer water above. In India and parts of Southeast Asia, people placed copper or brass containers filled with water in direct sunlight. This method, now known as solar disinfection, used ultraviolet radiation from the sun to kill harmful microorganisms. The ancient Greeks understood the concept of water filtration and used sand and gravel filters to remove sediment and improve water clarity. The Romans built extensive aqueduct systems to transport water from distant sources to their cities. Along these aqueducts, they constructed settling tanks where water would slow down, allowing sediment to sink to the bottom. They also used domestic filters made of cloth to strain out impurities from their drinking water. In China, people boiled water as early as 1,000 years before the Common Era, recognizing that this process made water safer to drink. This practice spread to other cultures and remains one of the most effective methods of water purification. These ancient techniques laid the foundation for modern water treatment methods, demonstrating the long history of human innovation in ensuring access to clean water. Ancient megalithic structures often display remarkable acoustic properties that continue to fascinate researchers and visitors alike. These massive stone monuments, built thousands of years ago, seem to interact with sound in ways that suggest their creators may have had a sophisticated understanding of acoustics. Many megalithic chambers and stone circles exhibit resonance frequencies that amplify certain sounds while dampening others. For example, some structures resonate at frequencies that match those of human chanting or drumming, creating an immersive auditory experience for those inside. This effect is particularly noticeable in passage tombs and enclosed chambers, where sound waves can bounce off the carefully positioned stone surfaces. Another intriguing acoustic feature found in some megalithic sites is the presence of sound focusing points. These are specific locations within the structure where sound appears to converge, creating areas of increased volume or clarity. Some researchers speculate that these acoustic hotspots may have been intentionally designed for ritual or ceremonial purposes. Interestingly, certain megalithic structures also demonstrate the ability to filter out external noise, creating a sense of isolation from the outside world. This acoustic isolation, combined with the unique sound properties within the structures, might have contributed to altered states of consciousness or enhanced spiritual experiences for ancient peoples during ceremonies or rituals conducted at these sites. Ancient cultures, particularly the Greeks and Romans, mastered the art of creating acoustically superior amphitheaters through a combination of intuitive design and practical experimentation. These remarkable structures, some of which still stand today, demonstrate an advanced understanding of sound propagation that predates modern acoustic science by millennia. The key to their acoustic excellence lies in the careful shaping of the theater itself. Ancient architects discovered that a semicircular or horseshoe shape effectively funneled sound from the stage to the audience. This design, coupled with steeply tiered seating, allowed sound waves to travel unobstructed to even the furthest rows. Another crucial element was the use of specific materials and textures. Hard, smooth surfaces like marble were often employed to reflect sound efficiently. In some cases, architects incorporated resonating vessels or cavities beneath the seating areas to amplify and enhance certain frequencies, creating a natural sound system. The stage itself played a vital role in projecting actors' voices. Many amphitheaters featured a raised stage with a backdrop wall, which helped to direct sound towards the audience. Some even included sophisticated canopies or awnings above the stage to further focus the sound. These ancient acoustic marvels continue to inspire modern architects and serve as a testament to the ingenuity of our ancestors in creating spaces where every whisper could be heard clearly by thousands. Archaeological findings and historical records provide intriguing glimpses into ancient civilizations' understanding of sound healing. In ancient Egypt, hieroglyphs depict the use of sound in medical treatments, with specific instruments and chants believed to promote healing. The famous Dendra temple complex contains carvings that some researchers interpret as representations of sound therapy devices. Ancient Greek physicians, including Hippocrates, recognized the therapeutic potential of music. They prescribed specific musical modes to treat various ailments, believing that different melodies could influence the body and mind. This practice, known as music therapy, was an integral part of their holistic approach to medicine. In India, the ancient practice of mantra chanting, dating back thousands of years, was believed to have profound effects on physical and mental well-being. The Vedic texts describe the use of specific sound frequencies to balance the body's energy centers or chakras. Similarly, Tibetan singing bowls, used for centuries in meditation and healing rituals, demonstrate a sophisticated understanding of sound vibrations and their effects on human physiology. Native American cultures have long employed drumming and chanting in healing ceremonies. The rhythmic patterns and frequencies produced during these rituals were thought to induce altered states of consciousness and promote physical healing. This tradition, passed down through generations, suggests a deep-rooted belief in the power of sound to affect health and well-being. Pre-Columbian cultures in South America, particularly the Moche and Chimu civilizations, developed remarkable skill in crafting whistling vessels that produced specific, intentional tones. These ceramic artifacts, often shaped like animals or human figures, incorporated sophisticated acoustic principles that modern scientists are still working to fully understand. The key to creating precise tones lay in the vessel's intricate internal structures. Craftsmen designed complex chambers and air passages within the pottery, carefully controlling the size and shape of these internal spaces. When water was poured into the vessel and then tipped, air would be forced through narrow channels, creating a whistling sound. The pitch and quality of this sound depended on factors such as the volume of the chambers, the length and diameter of the air passages, and the shape of the whistling mechanism itself. Artisans likely refined their techniques through generations of experimentation and observation. They may have used a process of trial and error, adjusting the internal structures until they achieved the desired tones. Some researchers believe that these ancient potters might have had a deeper understanding of acoustic principles than previously thought, possibly developing empirical knowledge of sound wave behavior. The precision of these whistling vessels is even more impressive, considering they were created without modern measuring tools or acoustic equipment. This level of craftsmanship speaks to the ingenuity and skill of pre-Columbian artisans, as well as the cultural importance placed on sound and music in these ancient societies. The whistling vessels serve as a testament to the sophisticated technological and artistic achievements of these early American civilizations. Ancient Egyptian pyramids have revealed fascinating acoustic properties that continue to intrigue scientists and archaeologists. One of the most notable phenomena is the presence of strong echoes and reverberations within the internal chambers. These acoustic effects are particularly pronounced in the King's Chamber of the Great Pyramid of Giza. When a sound is made inside this chamber, it reverberates and amplifies, creating a rich, resonant effect. This amplification is believed to be due to the specific dimensions and materials used in the construction of the chamber. The hard, polished granite surfaces reflect sound waves efficiently, contributing to the sustained echoes. Another intriguing acoustic feature observed in some pyramids is the ability to focus sound energy. In certain locations within the structures, a person speaking at a normal volume can be heard clearly at a considerable distance, while the sound is much fainter in the intervening space. This effect, sometimes called acoustic focusing, has led to speculation about the intentional design of these structures for ceremonial or religious purposes. Researchers have also discovered that the pyramids can respond to certain frequencies of sound and vibration. Some studies suggest that the Great Pyramid might have resonant frequencies that align with the Earth's own vibrations. While the full implications of these acoustic properties are still debated, they add another layer of mystery to these ancient marvels and highlight the advanced knowledge of the ancient Egyptians in architecture and possibly acoustics. Sound has played a crucial role in religious and spiritual practices across ancient cultures worldwide. Many civilizations recognize the power of sound to evoke emotions, alter consciousness, and connect with the divine. In ancient Egypt, priests used sistrums, rattle-like instruments, during rituals to honor the goddess Hathor. The rhythmic sounds were believed to please the deities and drive away evil spirits. Similarly, in ancient Greece, music and chanting were integral to religious ceremonies, with the lyre often used in worship of Apollo, the god of music. Vedic traditions in ancient India placed great importance on the recitation of sacred texts and mantras. The precise pronunciation and intonation of these sounds were thought to have transformative effects on both the chanter and the universe. This practice continues in Hinduism today, with Om considered the primordial sound of creation. Native American cultures have long used drums, rattles, and vocal chanting in their spiritual ceremonies. These sounds are believed to facilitate communication with the spirit world and promote healing. The didgeridoo, used by indigenous Australians for thousands of years, serves a similar purpose in dreamtime ceremonies and spiritual practices. Ancient civilizations developed ingenious methods for long-distance communication, and evidence suggests that sound played a crucial role. In the Andes Mountains of South America, the Inca civilization constructed an extensive network of stone structures known as huacas. These structures, strategically placed along mountain ridges, were designed to amplify and transmit sound over great distances. Acoustic studies have shown that messages could be relayed between huacas up to 20 miles apart, allowing for rapid communication across the vast Inca Empire. In Africa, the talking drums of West African cultures provide another example of sound-based long-distance communication. These drums, capable of mimicking the tonal patterns of spoken language, could transmit complex messages over distances of up to 100 miles. The effectiveness of this system was so remarkable that it continued to be used well into the 20th century, with skilled drummers able to convey nuanced information across vast stretches of forest and savanna. Ancient Greek and Roman civilizations also utilized sound for long-range communication. Archaeological evidence suggests the use of hydraulic organs and large bronze horns in military contexts. These instruments could produce powerful, low-frequency sounds that carried for miles, allowing commanders to signal troops and coordinate movements across battlefields and naval formations. In Mesoamerica, the ancient Maya constructed temples and plazas with specific acoustic properties. The famous El Castillo Pyramid at Chichen Itza, for instance, was designed to produce a chirping echo when someone clapped at its base. This sound, resembling the call of the quetzal bird, could be heard throughout the city, possibly serving as a form of public address system or ceremonial tool. Ancient cultures developed remarkably sophisticated musical instruments through a combination of careful observation, experimentation, and accumulated knowledge passed down through generations. Their understanding of acoustics, though not formalized as we know it today, was deeply intuitive and practical. Many ancient civilizations discovered the relationship between the length of a vibrating string or column of air and the pitch it produces. This knowledge allowed them to create instruments with specific tones by precisely measuring and cutting materials. For instance, pan flutes were crafted by cutting bamboo or reed pipes to exact lengths, each producing a different note when blown across. The development of stringed instruments involved similar principles. Luthiers in ancient China, Mesopotamia, and Egypt learned to create specific pitches by adjusting the length, tension, and thickness of strings. They often used natural harmonics as reference points, tuning strings to produce pleasing intervals when played together. Some cultures even developed complex mathematical systems to guide their instrument creation. The ancient Greeks, for example, used a system based on ratios to determine the placement of frets on stringed instruments, ensuring accurate pitch across the entire range of the instrument. This attention to detail and mathematical precision laid the groundwork for the development of Western musical scales and tuning systems that are still in use today. Ancient underground chambers and tunnels possess unique acoustic properties that have fascinated researchers and visitors for centuries. These subterranean spaces often exhibit remarkable sound characteristics due to their physical structure and the materials used in their construction. One of the most notable acoustic features found in these ancient chambers is reverberation. The hard, reflective surfaces of stone walls, floors, and ceilings cause sound waves to bounce repeatedly, creating a lingering echo effect. This reverberation can make even whispers audible throughout the chamber, amplifying and prolonging sounds in ways that seem almost magical to the human ear. Many underground chambers also display frequency-dependent resonance, where certain pitches or tones are naturally amplified within the space. This phenomenon occurs when the dimensions of the chamber align with specific wavelengths of sound, creating standing waves. As a result, some frequencies may be enhanced while others are diminished, leading to a unique acoustic signature for each location. Another intriguing property often observed in these ancient structures is sound focusing. Curved walls or domed ceilings can concentrate sound waves at specific points within the chamber, creating acoustic hotspots where sounds are particularly clear or loud. This effect was sometimes intentionally incorporated into the design of ceremonial or religious spaces to create areas of heightened auditory experience or to allow for secretive communication across large distances. Ancient civilizations recognized the power of sound as a formidable tool in warfare and defense. The use of sound ranged from practical communication to psychological warfare, demonstrating the ingenuity of our ancestors in leveraging auditory phenomena. One of the most common applications was the use of war drums and horns to coordinate troop movements and convey signals across vast distances. These instruments could be heard for miles, allowing armies to maintain cohesion and respond to changing battlefield conditions quickly. The Mongols, for instance, used a sophisticated system of drum signals to maneuver their cavalry with remarkable precision. Some civilizations employed sound as a weapon to instill fear in their enemies. The Celtic warriors were known to use an instrument called the carnix, a long bronze trumpet with an animal head-shaped bell. Its eerie, penetrating sound was designed to unnerve opponents before and during battle. Similarly, Roman legions used the cornu, a curved bronze horn, to intimidate enemies and boost the morale of their own troops. In terms of defense, many ancient cultures incorporated acoustic elements into their architecture. The Mayans built structures with specific acoustic properties that could amplify the voice of a single person, making it audible across great distances. This allowed for efficient communication within their cities and served as an early warning system against approaching enemies. These examples highlight how ancient civilizations harnessed the power of sound, turning it into a versatile asset for both offensive and defensive military strategies. The ancient Egyptians demonstrated remarkable mathematical prowess, especially in their approximation of pi. Their method for calculating this fundamental constant was both ingenious and practical, rooted in their everyday construction and surveying needs. The key to their approach lay in a concept known as the sekhed, which was essentially the slope of a pyramid's face. By measuring the sekhed of a circular object, they could derive a reasonably accurate value for pi. One of the most famous examples of this calculation comes from the Rhind mathematical papyrus, dating back to around 1850 BCE. In this ancient document, the scribe Ahmes presents a problem involving a circular field with a diameter of 9 units. He then calculates the area of a square with sides 8 units long, effectively inscribing the circle within this square. This method yielded a value for pi of approximately 3.16, which is remarkably close to the actual value, differing by less than 1%. The Egyptians' practical approach to mathematics, driven by the needs of architecture and land management, led them to develop methods that were not only effective, but also surprisingly accurate for their time. Their work laid a foundation for future mathematicians and continues to impress scholars today with its elegance and precision. Recent archaeological discoveries have shed new light on the mathematical knowledge of ancient Babylonians, challenging the long-held belief that the concept of zero originated in India. Clay tablets dating back to around 2,000 years before the Common Era have been found in Mesopotamia, the region between the Tigris and Euphrates rivers in modern-day Iraq, which was once home to the Babylonian civilization. These tablets contain complex astronomical calculations and use a placeholder symbol to denote an empty column in their sexagesimal or base 60 number system. This placeholder served a similar function to our modern zero, allowing for more accurate and sophisticated mathematical operations. The Babylonians used this symbol consistently in their calculations, demonstrating a clear understanding of the need for a placeholder in positional notation. While the Babylonians may not have conceived of zero as an abstract number in the same way we do today, their use of a placeholder symbol represents a significant step towards the development of the concept. This discovery predates the earliest known Indian use of zero by over 1,000 years, suggesting that the roots of this crucial mathematical concept may lie in ancient Mesopotamia rather than the Indian subcontinent. It is important to note that mathematical ideas often evolve independently in different cultures. The Babylonian use of a zero placeholder does not diminish the significant contributions of Indian mathematicians who later developed a more complete understanding of zero as a number in its own right. Rather, it highlights the complex and interconnected nature of mathematical discovery throughout human history. Ancient cultures developed remarkably precise calendars through careful observation and meticulous record-keeping over many generations. These early astronomers tracked the movements of celestial bodies, noting patterns in the sun, moon, and stars. They recognized that these celestial cycles correlated with earthly changes like seasons, tides, and animal migrations. In Mesopotamia, priests observed the night sky from towering ziggurats, recording the positions of stars and planets. The Mayans of Central America created a complex calendar system that accurately predicted solar eclipses and Venus transits. Their long-count calendar spanned thousands of years, demonstrating their grasp of vast timescales. The ancient Egyptians based their calendar on the annual flooding of the Nile River, crucial for agriculture. They noticed this event coincided with the heliacal rising of Sirius, the brightest star in the night sky. This observation allowed them to create a calendar of 365 days, divided into 12 months of 30 days each, with 5 extra days added at the end of the year. These diverse cultures shared a common drive to understand and predict natural cycles. Their calendars were not merely practical tools, but also held religious and cultural significance. By linking celestial events to earthly concerns, these ancient timekeepers laid the foundation for our modern understanding of astronomy and the passage of time. Ancient civilizations left behind remarkable architectural marvels that continue to astound us with their precision and complexity. These structures often reveal a deep understanding of mathematical principles far beyond what we might expect from ancient societies. The Great Pyramid of Giza in Egypt demonstrates an impressive grasp of geometry and proportion. Its builders incorporated the mathematical constant pi into its design, with the ratio of its perimeter to height being approximately 2 times pi. This suggests that ancient Egyptians had knowledge of this fundamental constant thousands of years before it was formally defined by mathematicians. In Mesoamerica, the Maya built temples that showcase their advanced understanding of astronomy and mathematics. The El Castillo Pyramid at Chichen Itza is designed so that during the spring and autumn equinoxes, sunlight creates the illusion of a serpent descending the stairs. This required precise calculations of the sun's position and the pyramid's orientation. Ancient Greek architecture, exemplified by the Parthenon in Athens, embodies the concept of the golden ratio. This mathematical relationship, found throughout nature, was used to create aesthetically pleasing proportions in columns, facades, and overall building design. The Greeks' use of this ratio reflects their deep appreciation for the harmony between mathematics and beauty. Ancient civilizations achieved remarkable precision in calculating celestial movements through centuries of careful observation and meticulous record-keeping. Cultures like the Babylonians, Egyptians, and Maya developed complex systems to track the positions of celestial bodies over long periods of time. These early astronomers noticed repeating patterns in the sky, such as the phases of the moon and the positions of planets. By documenting these cycles over many years, they could predict future celestial events with surprising accuracy. The Babylonians, for instance, discovered the Saros cycle, which allows the prediction of eclipses. Many ancient cultures built specialized structures to aid their observations. The Greeks used devices like the Antikythera mechanism, an intricate analog computer that could calculate astronomical positions. The Maya constructed observatories aligned with specific celestial events, allowing them to create highly accurate calendars. These ancient astronomers laid the groundwork for modern celestial mechanics. Their methods, though lacking modern technology, demonstrated the power of patient observation and pattern recognition in understanding the cosmos. Their achievements continue to astound us today, bridging the gap between ancient wisdom and modern scientific understanding. Ancient cultures across the globe have left behind remarkable artifacts and structures that demonstrate a sophisticated understanding of geometry. The Great Pyramid of Giza in Egypt stands as a testament to the mathematical prowess of its builders. Its near-perfect square base and precise alignment with the cardinal directions reveal a deep grasp of angular measurements and spatial relationships. In South America, the Nazca lines of Peru showcase intricate geometric patterns visible only from great heights. These enormous geoglyphs, some spanning hundreds of meters, exhibit a mastery of scale and proportion that continues to astonish researchers. The precision required to create such massive yet accurate designs implies a thorough comprehension of geometric principles. The celestial alignments of ancient structures provide further evidence of geometric knowledge. Stonehenge in England, with its carefully positioned stones, aligns with solstices and equinoxes, indicating an understanding of astronomical geometry. Similarly, the Maya city of Chichen Itza features buildings designed to create specific light and shadow effects during equinoxes, demonstrating a blend of architectural and celestial geometry. Ancient Indian texts like the Sulba Sutras contain early discussions of geometric concepts, including the Pythagorean theorem, centuries before Pythagoras. These writings reveal that complex geometric ideas were not only understood, but also formally documented in some ancient cultures, further cementing the notion that geometric principles were widely recognized and applied in antiquity. The Mayan civilization, renowned for its advanced mathematical and astronomical knowledge, developed a sophisticated vigesimal number system that was quite different from the decimal system we use today. This system, based on the number 20 rather than 10, likely evolved from the simple act of counting fingers and toes. The Mayans used a combination of dots and bars to represent numbers. A dot represented 1, while a bar represented 5. This elegant system allowed them to express large numbers with relatively few symbols. They also introduced the concept of 0, represented by a shell-like symbol, long before many other civilizations grasped this crucial mathematical concept. The vigesimal system was particularly well suited to the Mayan calendar calculations. Their complex calendar system required precise long-term calculations, and the vigesimal system provided an efficient way to perform these computations. The Mayans used this number system to track vast periods of time, creating calendar cycles that spanned thousands of years. Interestingly, the Mayan number system also incorporated a positional notation, similar to our modern decimal system. Each position represented a power of 20, allowing for the representation of extremely large numbers. This advanced understanding of mathematics played a crucial role in Mayan astronomy, architecture, and trade, contributing to the overall sophistication of their civilization. Ancient civilizations often incorporated mathematical concepts into their artwork and symbols, revealing a deep understanding of geometry and numerical relationships. The golden ratio, a proportion found in nature, appears in the design of the Great Pyramid of Giza and in classical Greek architecture. This ratio, approximately 1.618 to 1, was believed to represent divine harmony and aesthetic perfection. Sacred geometry, the belief that certain geometric shapes and proportions have spiritual significance, influenced the creation of mandalas in Hindu and Buddhist traditions. These intricate circular designs often feature symmetry, fractals, and other complex mathematical patterns. Similarly, Islamic art showcases elaborate tessellations and geometric patterns, demonstrating an advanced grasp of symmetry and repetition. The ancient Egyptians used a grid system in their artwork, dividing the human form into 18 equal parts to maintain consistent proportions. This mathematical approach to representation ensured accuracy and uniformity in their depictions of people and deities. In Mesoamerica, the Maya incorporated their vigesimal number system into their artwork and architecture, with many structures featuring elements in multiples of 20. Spirals, which follow mathematical sequences like the Fibonacci series, appear in various ancient symbols worldwide. The Celtic triple spiral, or triskele, and the Greek meander pattern both embody this concept. These mathematical elements in ancient art not only served aesthetic purposes, but also often held deep cultural and spiritual significance, reflecting the sophisticated numerical understanding of our ancestors. Ancient cultures developed ingenious methods for performing complex calculations without the benefit of modern numerals. The Babylonians, for instance, used a base 60 number system and clay tablets to solve intricate mathematical problems. They created tables for multiplication and division, allowing them to tackle advanced astronomy and engineering tasks. In ancient Egypt, scribes employed a decimal system and hieroglyphic symbols for numbers. They used addition and subtraction extensively and had special methods for multiplication and division. Egyptian mathematicians could calculate the volume of cylinders and the area of circles with remarkable accuracy. The Chinese utilized a counting board called a xuanpan, similar to an abacus, for rapid calculations. This tool allowed them to perform addition, subtraction, multiplication, and division quickly and efficiently. The ancient Chinese also developed algebraic methods to solve complex equations. The Maya civilization of Central America created a vigesimal or base 20 number system. They used this system to make precise astronomical calculations, predicting eclipses and planetary movements with astonishing accuracy. These diverse approaches demonstrate the ingenuity of ancient cultures in overcoming the limitations of their numerical systems to achieve mathematical breakthroughs. Ancient civilizations across the world demonstrated a surprising grasp of infinity, leaving behind intriguing clues in their mathematics, philosophy, and art. In ancient India, mathematicians and philosophers explored the concept of infinity through their understanding of time and space. The Jain tradition, for instance, divided time into infinite cycles, each lasting unimaginably long periods. The ancient Greeks also grappled with the concept of infinity. Zeno of Elea famously proposed paradoxes that dealt with infinite divisibility, challenging our understanding of motion and space. These paradoxes continue to perplex philosophers and mathematicians to this day. Meanwhile, Aristotle distinguished between potential and actual infinity, laying the groundwork for later mathematical developments. In ancient Egypt, the symbol of the Ouroboros, a serpent eating its own tail, represented eternity and the infinite cycle of life and death. This symbol appeared in various forms across different cultures, suggesting a widespread contemplation of endless cycles and timelessness. The Mayans of Central America developed a sophisticated understanding of large numbers and cycles of time. Their long count calendar system could theoretically continue indefinitely, hinting at their grasp of vast timescales and potentially infinite cycles. These examples from diverse cultures show that the concept of infinity, while complex, was not beyond the reach of ancient minds. Ancient civilizations developed sophisticated methods to understand and anticipate long-term climate changes, relying on careful observation and record-keeping. The Mayans of Central America, for instance, meticulously tracked celestial movements and weather patterns, creating complex calendars that helped them predict seasonal changes and plan their agricultural activities accordingly. In ancient Egypt, the annual flooding of the Nile River was crucial for agriculture. Egyptians used nilometers, structures built along the riverbank, to measure and record water levels. These records, maintained over centuries, allowed them to identify patterns and prepare for years when floods might be too high or too low, affecting crop yields. Chinese dynasties kept detailed weather records for thousands of years, noting unusual events like droughts, floods, and unseasonable cold spells. This wealth of data enabled them to recognize climate cycles and adapt their farming practices. They developed complex irrigation systems and crop rotation techniques to mitigate the effects of changing weather patterns. Native American tribes in North America passed down knowledge of climate patterns through oral traditions and stories. They learned to read subtle environmental cues, such as changes in plant and animal behavior, to predict shifts in weather and climate. This traditional ecological knowledge allowed them to adjust their hunting, gathering, and planting practices in response to long-term environmental changes. Archaeological discoveries across the globe reveal that many ancient civilizations developed sophisticated water management systems far earlier than previously thought. In Mesopotamia, often called the cradle of civilization, intricate networks of canals and aqueducts dating back over 4,000 years have been unearthed. These systems transported water from rivers to agricultural fields, supporting large-scale farming in an otherwise arid region. The ancient Egyptians also demonstrated remarkable hydraulic engineering skills. They created an elaborate irrigation system along the Nile River, using nilometers to measure water levels and predict floods. This allowed them to maximize agricultural productivity in the fertile Nile Valley, supporting a thriving civilization for millennia. In South America, the Nazca culture of Peru constructed an extensive network of underground aqueducts known as puquios. These underground channels, some still functioning today, brought water from mountain springs to settlements in the desert. The engineering precision required to build these sloping tunnels over long distances speaks to the advanced knowledge of hydrology possessed by the Nazca people. Perhaps most impressive are the water management systems of the ancient city of Angkor in Cambodia. Satellite imagery and ground surveys have revealed a vast hydraulic network spanning over 1,000 square kilometers. This complex system of reservoirs, canals, and distribution channels allowed the Khmer Empire to thrive in a challenging monsoon climate, supporting a population of up to 1 million people at its peak. Ancient civilizations developed ingenious methods to regulate temperatures in their buildings, demonstrating remarkable understanding of heat transfer and architectural design. In ancient Egypt, thick mud brick walls acted as excellent insulators, keeping interiors cool during scorching days and warm during chilly nights. Clever Egyptians also utilized wind catchers, tall structures with openings facing prevailing winds, to funnel breezes into buildings and create natural ventilation. The Romans took climate control to new heights with their hypocauste system, an early form of central heating. This consisted of raised floors supported by pillars, creating a space underneath where hot air from furnaces circulated. The warmth radiated through the floor and walls, effectively heating entire buildings. In addition, Romans used double-paned windows to trap heat, a technique that is still employed in modern architecture. In the arid regions of the Middle East, ancient Persians developed an early form of air conditioning called qanats. These were underground channels that transported cool water from mountain springs to urban areas. As hot surface air was drawn down into these channels, it was cooled by the water and then circulated through buildings, creating a refreshing environment even in the hottest months. The Mayans and Aztecs in Central America utilized the principle of evaporative cooling. They constructed their cities near water bodies and incorporated fountains and pools in their designs. As water evaporated, it absorbed heat from the surrounding air, effectively lowering temperatures in public spaces and homes. These diverse approaches highlight the resourcefulness of ancient peoples in creating comfortable living spaces using the materials and knowledge available to them. Ancient cultures developed various techniques to predict weather patterns, relying heavily on observation and pattern recognition. One common method was studying cloud formations and colors in the sky. Red skies at night often indicated fair weather the next day, while red skies in the morning suggested approaching storms. Many civilizations also observed animal behavior as a weather indicator. For instance, birds flying low to the ground or cows lying down in fields were seen as signs of impending rain. The ancient Greeks even used this knowledge to create weather vanes, with Athenian astronomer Andronicus designing the first one in the 1st century BCE. Lunar observations played a crucial role in weather forecasting as well. Many cultures believed that the moon's appearance could predict atmospheric conditions. A ring around the moon, for example, was thought to foretell rain or snow within the next few days. Some ancient societies developed more sophisticated methods. The Babylonians used astrology to predict weather patterns, while Chinese astronomers created detailed calendars based on celestial observations to forecast seasonal changes. These early techniques laid the groundwork for modern meteorology, demonstrating our ancestors' remarkable ability to understand and interpret natural phenomena. Ancient civilizations displayed remarkable ingenuity in adapting to extreme environments, developing innovative solutions to survive and thrive in challenging conditions. In desert regions, societies like the ancient Egyptians and Nabateans mastered water management techniques. They created sophisticated irrigation systems, built underground aqueducts, and designed clever water storage facilities to make the most of scarce rainfall. In the scorching heat, these desert dwellers constructed homes with thick walls to insulate against daytime temperatures and utilized wind-catching towers to funnel cooler air inside. They also adjusted their daily routines, conducting most activities during cooler morning and evening hours while seeking shelter during the hottest parts of the day. In stark contrast, Arctic civilizations like the Inuit developed entirely different strategies to cope with their frigid surroundings. They crafted warm, waterproof clothing from animal skins and furs, crucial for survival in sub-zero temperatures. Their iconic igloos, made from compacted snow, provided excellent insulation against the bitter cold. These northern peoples also perfected hunting techniques for Arctic wildlife, using every part of their prey for food, tools, and materials. They developed specialized equipment like kayaks and dog sleds for transportation across ice and snow, enabling them to cover vast distances in search of resources. Through these adaptations, ancient civilizations not only survived, but flourished in some of Earth's most challenging environments. Ancient cultures demonstrated a remarkable understanding of microclimates through their agricultural practices and settlement patterns. Archaeological evidence reveals that early civilizations strategically positioned their farms and communities to take advantage of local climate variations. In the Andes Mountains, the Inca built terraced farms on hillsides, effectively creating different microclimates at various elevations. This allowed them to grow a diverse range of crops, from warm weather plants at lower altitudes to cold-resistant varieties higher up. The Incas' sophisticated understanding of these microclimates enabled them to maximize food production in challenging mountain environments. Similarly, ancient Mediterranean cultures utilized microclimates in their agricultural practices. Greek and Roman farmers were known to plant olive trees on south-facing slopes to capture more sunlight and warmth, while reserving north-facing slopes for crops that required cooler conditions. This deliberate placement demonstrates an intuitive grasp of how topography influences local climate conditions. In Mesoamerica, the Maya civilization constructed their cities with careful consideration of local microclimates. They built reservoirs and canals to manage water resources, creating artificial microclimates that supported agriculture in otherwise challenging environments. These engineering feats reveal a deep understanding of how landscape modifications could alter local climate conditions to their advantage. Ancient civilizations faced significant challenges from flooding, particularly those settled near major rivers. They developed ingenious solutions to manage these water-related risks. In Mesopotamia, the Sumerians constructed networks of canals and levees to divert floodwaters from the Tigris and Euphrates rivers. These systems not only protected their cities, but also allowed them to irrigate farmland during drier seasons. The ancient Egyptians similarly harnessed the power of the Nile River. They created a sophisticated system of basins and canals to capture and store floodwater. This approach helped them control the annual floods and use the water for agriculture throughout the year. The Egyptians also built nilometers, structures that measured the water levels of the Nile, allowing them to predict and prepare for floods. In China, the Qin and Han dynasties implemented large-scale flood control projects. The most famous of these was the Dujiangyan irrigation system, built around 2,200 years ago. This system split the Min River into inner and outer flows, effectively managing floodwaters and providing irrigation to the Chengdu Plain. It continues to function to this day, showcasing the longevity and effectiveness of ancient engineering. The Romans also excelled in water management, constructing elaborate aqueducts and sewage systems. While primarily used for water supply and sanitation, these systems also played a role in flood control by efficiently channeling excess water away from populated areas. These ancient flood control methods demonstrate the ingenuity and adaptability of early civilizations in the face of environmental challenges. Ancient cultures developed sophisticated techniques for soil conservation and management, demonstrating remarkable ingenuity in preserving their agricultural resources. One of the most widespread methods was terracing, practiced by civilizations from the Inca in South America to the ancient Chinese. By creating level platforms on hillsides, terraces prevented soil erosion, conserved water, and increased cultivable land area. In Mesoamerica, the Aztecs devised an innovative system called chinampas. These were artificial islands created in shallow lake beds using layers of vegetation, mud, and soil. This method not only reclaimed land for agriculture, but also provided incredibly fertile soil that could support multiple harvests per year. The ancient Egyptians relied on the annual flooding of the Nile River to replenish soil nutrients. They developed a complex system of irrigation canals and basins to control the floodwaters and distribute nutrient-rich silt across their fields. This allowed them to maintain soil fertility in an otherwise arid region. In the Mediterranean, Roman farmers practiced crop rotation, alternating between different crops to prevent soil depletion. They also used cover crops, such as legumes, which added nitrogen to the soil. These techniques, combined with careful manure management, helped maintain soil productivity over long periods, supporting the vast Roman Empire's agricultural needs. Ancient civilizations faced numerous climate challenges, forcing them to develop innovative agricultural techniques. In Mesopotamia, farmers created complex irrigation systems to manage water from the Tigris and Euphrates rivers. They dug canals and built dams to control flooding and distribute water to their crops during dry periods. This allowed them to cultivate crops in an otherwise arid region. In ancient Egypt, the annual flooding of the Nile River brought nutrient-rich silt to the farmlands. Egyptians developed a system called basin irrigation, where they divided the land into sections using earthen walls. When the Nile flooded, these basins would fill with water and silt, creating fertile ground for planting after the waters receded. The Maya civilization in Central America faced periods of severe drought. They responded by creating raised fields in swampy areas and terracing hillsides to maximize arable land and conserve water. They also developed sophisticated water management systems, including reservoirs and canals, to collect and distribute rainwater efficiently. In the Andes, the Inca civilization adapted to the challenging mountain environment by developing a unique agricultural system called vertical farming. They created terraces on steep slopes, allowing them to cultivate crops at different altitudes. This technique not only prevented soil erosion, but also allowed them to grow a variety of crops suited to different microclimates. Ancient civilizations demonstrated a remarkable understanding of the connection between forests and climate, often far beyond what we might expect. Archaeological and historical evidence reveals that some cultures implemented practices to protect forests, recognizing their importance in maintaining local weather patterns and environmental stability. In ancient China, records from as far back as 4,000 years ago describe the effects of deforestation on local climates. Chinese texts warned about the consequences of clearing forests, noting changes in rainfall patterns and increased flooding in deforested areas. This knowledge led to the implementation of forest conservation policies during various dynasties, aimed at preserving the balance between human needs and environmental stability. Similarly, in pre-Columbian Mesoamerica, the Maya civilization showed an advanced understanding of forest ecology. Studies of Mayan agricultural practices reveal sophisticated systems of forest management that maintained biodiversity and protected against soil erosion. The Maya recognized that preserving forests helped regulate rainfall and prevent drought, crucial factors in sustaining their urban centers and agricultural production. Even in ancient Greece, philosophers like Plato wrote about the detrimental effects of deforestation on the landscape and climate. Plato observed that the hills of Attica had been stripped of trees, leading to increased runoff and soil erosion. This awareness of the relationship between forests and environmental conditions demonstrates that ancient cultures often possessed a nuanced understanding of ecological systems, challenging our assumptions about the development of environmental science. Archaeological discoveries have revealed intriguing hints that some ancient civilizations may have possessed rudimentary knowledge of electricity. One of the most famous examples is the Baghdad battery, a clay pot containing an iron rod surrounded by a copper cylinder, discovered in Iraq and dating back to the Parthian period, around 2,000 years ago. When filled with an acidic liquid, this device could have generated a small electrical charge. In ancient Egypt, elaborate carvings in the Temple of Dendera depict what some interpret as large light bulbs. These controversial images show snake-like filaments within bulb-shaped objects, leading to speculation about advanced lighting systems in Egyptian temples. However, mainstream archaeologists dispute this interpretation, suggesting the carvings represent symbolic religious imagery instead. Some researchers point to ancient Indian texts that describe a weapon called the Vajra, often translated as thunderbolt, which some believe might reference electrical phenomena. Similarly, certain passages in the Bible have been interpreted by a few scholars as possibly alluding to electrical effects, though these interpretations remain highly debated. While these examples are intriguing, it is important to note that there is no conclusive evidence of widespread understanding or practical application of electricity in ancient civilizations. Many of these claims remain controversial, and the mainstream scientific community generally views them with skepticism. Nevertheless, they continue to fuel fascinating discussions about the potential technological achievements of our ancestors. Ancient cultures across the globe recognized the potential of geothermal energy long before modern science understood its origins. The Romans, renowned for their engineering prowess, were among the first to harness this natural heat source on a large scale. They constructed elaborate bathhouses and heating systems that tapped into hot springs and steam vents, creating luxurious spaces for relaxation and socializing. In New Zealand, the Maori people have utilized geothermal resources for cooking, heating, and medicinal purposes for over 700 years. They developed ingenious methods to channel steam and hot water from geothermal areas to create natural ovens and hot pools, integrating this energy seamlessly into their daily lives and cultural practices. The ancient Chinese also recognized the value of geothermal energy, using hot springs for bathing and therapeutic purposes as far back as the Han Dynasty over 2,000 years ago. They believed in the healing properties of these natural hot waters and developed sophisticated bathing rituals around them. In Iceland, settlers harnessed geothermal heat for warmth and cooking as early as the 9th century. The abundance of geothermal activity on this volcanic island allowed its inhabitants to thrive in an otherwise harsh environment, laying the groundwork for the country's modern-day leadership in geothermal energy utilization. Ancient civilizations demonstrated a surprising understanding of magnetism, far beyond what many might expect. The earliest known reference to magnetic phenomena dates back to ancient China, where lodestones were described in texts from around 1000 BCE. These naturally magnetized pieces of magnetite were used to create primitive compasses for navigation and geomancy. In ancient Greece, the philosopher Thales of Miletus wrote about the strange properties of lodestones as early as 600 BCE. He noted their ability to attract iron, sparking curiosity about this mysterious force. The Greeks even named the mineral magnetite after the region of Magnesia, where it was commonly found. Perhaps most intriguing is the potential use of magnetism in ancient construction. Some researchers suggest that certain megalithic structures, such as those found in Egypt and South America, may have been built using magnetic tools to align massive stone blocks with remarkable precision. While this theory remains controversial, it highlights the ongoing fascination with ancient technological capabilities. The understanding of magnetism in ancient times extended beyond mere observation. Indian medical texts from around 600 BCE describe the use of magnets in surgery, suggesting a practical application of this knowledge. This early grasp of magnetic properties laid the groundwork for future scientific discoveries, demonstrating that our ancestors were more technologically savvy than often credited. Ancient civilizations developed remarkably effective heating systems that still impress engineers today. The Romans, in particular, were masters of this technology. They created a system called hypocaust, which circulated hot air beneath the floors and through the walls of buildings. This ingenious method provided even consistent warmth throughout entire structures. The hypocaust system worked by raising the floor on pillars, creating a space underneath where hot air could flow. Furnaces outside the building burned wood or charcoal, generating heat that was then channeled through this underfloor space. The warm air would rise through flues in the walls, effectively heating the entire building from the ground up. This efficient system was not limited to Rome. In Korea, a similar method called ondol was developed independently. It used a comparable underfloor heating concept, often fueled by the same fire used for cooking. The heat from the kitchen stove would be directed under the floor, warming the living spaces. These ancient heating systems demonstrate the ingenuity of our ancestors. They understood principles of thermodynamics and heat transfer long before these concepts were formally defined. Their practical application of these ideas resulted in comfortable living spaces that rivaled modern heating systems in efficiency and effectiveness. Ancient cultures across the globe demonstrated a remarkable understanding of energy conservation, even without the formal scientific framework we have today. In ancient Egypt, the positioning and construction of the pyramids show an advanced grasp of solar alignment and energy efficiency. The structures were designed to capture and retain heat during cold desert nights, while reflecting intense sunlight during the day. Similarly, ancient Chinese practices of feng shui incorporated principles of energy flow and conservation in architecture and city planning. Buildings were strategically positioned to maximize natural light and warmth while minimizing exposure to harsh winds, effectively conserving energy resources. In Mesoamerica, the Maya built their cities with a sophisticated understanding of water management and energy conservation. They created complex systems of reservoirs and canals to collect and distribute rainwater efficiently, demonstrating an intuitive grasp of potential and kinetic energy conversion. The ancient Greeks also exhibited an understanding of energy conservation through their use of passive solar design in buildings. Socrates described ideal home designs that would be cool in summer and warm in winter, showcasing an early comprehension of thermal energy principles that we still apply in modern, sustainable architecture. Ancient civilizations recognized the potential of wind power and ingeniously harnessed it for a variety of purposes. One of the earliest and most significant applications was in sailing ships. Egyptians were among the first to use sails on boats around 5,000 years ago, allowing them to navigate the Nile River and eventually venture into the Mediterranean Sea. This innovation revolutionized trade and exploration, enabling civilizations to connect and exchange goods over vast distances. On land, windmills emerged as a crucial technology. The Persians developed vertical axis windmills as early as 200 BCE, using them to grind grain and pump water for irrigation. These early windmills consisted of a series of vertical sails attached to a central shaft, which rotated as the wind blew through them. The technology spread to other parts of Asia and eventually reached Europe during the Middle Ages. In China, wind power was harnessed for an unusual but effective purpose: to power trip hammers for husking rice and crushing ore in the metal working process. This application demonstrates the versatility of wind power and the ingenuity of ancient engineers in adapting it to their specific needs. The Greeks and Romans also utilized wind power, albeit in more limited ways. They developed wind wheels for organs and other mechanical devices, showcasing an early understanding of how wind energy could be converted into mechanical work. These civilizations laid the groundwork for future innovations in wind power technology, which would continue to evolve and play a crucial role in human development for millennia to come. Ancient civilizations demonstrated remarkable insight into solar energy and its potential uses. Archaeological evidence suggests that as far back as 5,000 years ago, people were harnessing the power of the sun in innovative ways. In ancient Egypt, for instance, the positioning of the Great Pyramids shows a sophisticated understanding of solar patterns. These massive structures were aligned with incredible precision to the cardinal points, allowing them to capture and reflect sunlight in specific ways during solstices and equinoxes. This alignment wasn't merely symbolic, it served practical purposes in ancient Egyptian culture and religion. The Greeks and Romans also showed advanced knowledge of solar energy utilization. They designed their buildings to maximize natural light and heat. South-facing windows became a common feature in Greek architecture around 2,500 years ago, allowing low winter sun to warm interiors while blocking the high summer sun. The Romans took this concept further, developing early forms of greenhouses to grow exotic plants and creating large south-facing windows covered with transparent materials like mica to trap heat. In the Americas, ancient Pueblo peoples constructed their cliff dwellings to take advantage of the sun's seasonal movements. These structures were built to allow winter sunlight to penetrate deep into living spaces for warmth, while summer sunlight was blocked by overhanging cliffs, keeping the interiors cool. This sophisticated design shows a deep understanding of solar patterns and their practical applications in daily life. Ancient cultures developed ingenious methods to illuminate their structures using natural light. One of the most remarkable techniques was the strategic placement of windows and openings to maximize sunlight penetration. In ancient Egyptian temples, for instance, architects designed narrow slits in the walls that allowed sunlight to enter at specific angles, creating dramatic lighting effects and highlighting important religious symbols. The Romans took natural lighting to new heights with their development of the oculus, a circular opening in the dome of a building. The Pantheon in Rome showcases this brilliantly, featuring a massive oculus that floods the interior with light and creates a moving spotlight effect as the sun traverses the sky. This not only provided illumination, but also served as a symbolic connection between the earthly realm and the heavens. In the Americas, ancient Mayan and Aztec builders incorporated precise astronomical alignments into their structures. They positioned doorways and windows to capture sunlight during solstices and equinoxes, creating stunning visual displays that marked important calendar dates. These alignments often illuminated specific sculptures or architectural features, adding layers of meaning to the buildings. Some cultures also utilized reflective surfaces to enhance natural lighting. Polished metals or water features were strategically placed to bounce light into darker areas of buildings. This technique was particularly effective in underground structures or rooms without direct access to sunlight, allowing ancient peoples to create well-lit spaces even in challenging environments. Ancient civilizations demonstrated a remarkable understanding of energy transformation through their technological achievements and cultural practices. In ancient Egypt, the use of water clocks, known as clepsydras, showed an understanding of potential energy being converted to kinetic energy. These devices used the steady flow of water to measure time, effectively harnessing gravitational potential energy. The Mayans and Aztecs also exhibited knowledge of energy transformation in their ball games. The rubber balls used in these games displayed elastic potential energy when compressed and kinetic energy when in motion. This understanding was not just limited to entertainment, but held deep cultural and religious significance. In ancient China, the invention of the kite around 2,500 years ago showcased an understanding of the conversion between kinetic and potential energy. Kites harnessed the wind's kinetic energy, transforming it into potential energy stored in the tension of the string. This technology later influenced the development of early flying machines. The ancient Greeks, particularly through the works of Hero of Alexandria, demonstrated an understanding of pneumatics and steam power. His aeolipile, a simple steam turbine, converted thermal energy to mechanical energy, laying the groundwork for future steam engine development. These examples highlight that while ancient civilizations may not have had our modern scientific terminology, they certainly grasped and applied the fundamental principles of energy transformation in their daily lives and technological advancements. Ancient cultures across the globe developed fascinating methods to potentially harness Earth's natural electromagnetic fields, though they lacked our modern scientific understanding. In ancient China, the practice of feng shui involved arranging buildings and objects to align with what they believed were Earth's energy flows. This practice, still popular today, may have inadvertently tapped into local variations in the planet's magnetic field. The mysterious ley lines of Europe, straight alignments connecting ancient sites, have been theorized to follow Earth's magnetic field lines. While this connection remains unproven, it's intriguing to consider that our ancestors might have sensed and utilized these invisible forces in their monumental constructions. In South America, some researchers speculate that the Nazca lines, enormous geoglyphs etched into the desert floor, could have been created to interact with Earth's electromagnetic fields. These theories suggest the lines might have been used for ceremonial purposes or even to manipulate weather patterns, though such claims remain highly speculative. Native American cultures often constructed medicine wheels, circular stone structures believed to have healing properties. Some modern theories propose these wheels might have been positioned to take advantage of local electromagnetic anomalies, potentially enhancing their perceived spiritual or medicinal effects. While these ideas are not scientifically verified, they highlight the intriguing ways ancient peoples may have interacted with Earth's natural electromagnetic environment.